ज्वाइनिंग नहीं हुआ, एक्सेप्ट ही नहीं है। अब एक्सेप्ट किया तो मुझे उसने बाद में ना हो जाता है कि रिवर्स क्या होगा। मोबाइल से ट्रस्ट किया है, चढ़ने में तो कोई भी चढ़ जाता है। जितना ये फुटेज है वही फुटेज मिलेगा। ये हो गया, यहाँ का काम हो गया और तो कुछ है नहीं यहाँ। चलो
कंप्लीट ये सर यहाँ आएंगे तो आएंगे, आके खोलेंगे ना।
तो कब आएंगे?
9 बजे का टाइम है।
तो इसको क्लोज करके रखिए।
हाँ क्लोज करके।
तो जब ये कामत सर रहेंगे
भैया चलो
কিন্তু তোমার কাছে ক্যামেরা তো আর নেই না, একটাই তো ক্যামেরা। এটা ট্রাইপড আছে, তাহলে এটা নিয়ে চলে যাও, যখন হবে আবার আসবে তুমি। তোমার কাছে আরেকটা লোকাল উইথ অডিও নিতে হবে।
Hello. Check. Hello. Hello. Hello.
হ্যাঁ হ্যাঁ করবো লিখতে দেবো।
আপনি একটা কাজ করুন, ভেতরটা আছে হসপিটাল ভারী সামানটা নিচে দিকে নিয়ে এখন ফেরাবে না, নিচে নিচে রেখে দিচ্ছি আমি, নিচে একটা রেখে দিই, এখানে দুটো ইনটা ওটা लेकिन वो तो फिर नहीं खोलना भी वो भी दिक्कत है, वो इनोग्रेशन होगा तभी खोलना।
এটা খোলা ব্লক করে নিয়ে
ठीक है।
ওম বিষ্ণু 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 পরমং পদম সদা বিষ্ণু তীষু রয় দেবী বজপ্রাতং পবিত্রবা সর্বাবস্থান মতো বিভাজস মদে পুণ্ডরীকাক্ষং সবজ্জবন্তরং সুচি ওং সর্বমঙ্গলমঙ্গলং বরণ্যং বরদং শুভং নারায়ণং নমস্কারয়েৎ ওং শঙ্খচক্রধরং দেবং দ্বিভুজং পিতবাসসং পারম্বে কর্মণাং বিপ্লব পুণ্ডরীকাক্ষং হরধরি ওং দেবী প্রপন্নার্তি হরে প্রসীদ প্রসীদ মাহ জগদখিলস্য प्रसीद विश्वेश्वरी प्राहि विश्वां तमेश्वरी देवी जरादशा आधारभूता जगतो सुमे कामही स्वरूपेण स्थितासि अपां सर्वस्थिता विनाशानां शक्तिभूते सनातने गुणाश्रयगुणमय नारायणी नमोस्तुते ओं शरणागति नार्थपरित्राणपरायणी सर्वसार्थरे देवी नारायणी नमोस्तुते ओं हं सवितुमानस्ते ब्रह्माण्डोधारिणे कौशंभस्कलिते देवी नारायणी नमोस्तुते ओं तिसचण्डाय हरे महाविश्ववाहिनी माहेश्वरी स्वरूपेण नारायण नमोस्तुते मयूरकुटुम्बिते महास्तिहरणगे कोमलस्तन नारायण नमोस्तुते शंख चक्र गदा शंख गृहीत परमायुधे प्रसीद विष्णु विरूपे नारायण नमोस्तुते ओं गृहीत चक्र महाचक्र संगरे पराकुरूपिणी शिवे नारायण नमोस्तुते लंबोदने शिरोमाला विभूषणे चामुण्डमुण्डमदने नारायण नमोस्तुते ओं लक्ष्मी लक्ष्मी हे महारात्रि महामाय नारायण नमोस्तुते ओं मेदे सरस्वती बड़े भूति प्रभु देशे नारायण नमोस्तुते ओं सर्वस्वरूपे सर्वेश्वरे सर्वशक्ति समन्वय देवाय पुत्राय देवी दुर्गे देवी नमोस्तुते एदत्ते भजनं सोमांगलजनतमुनां पादपत्ताय नमोस्तुते ओं इति गन्धपुष्पे ओं मंगलं भगवान् विष्णु मंगलं गरुडध्वज मंगलं हाँ सर आपको तो डिपार्टमेंट के ऊपर वाला है तो
यही वाला
बात
Hello.
চেয়ারটা সাইড করে দেবে চেয়ারটা তো গেছে 8:30 সময় বাড়ি গেছে तो काट फाट कोথায় রেখেছো মামা ভলেন্টিয়ার কাট ফাট কোথায় রেখেছো ওখানে যে থাকবে ওখানে তো দাঁড়াতে হবে একজন তো হয়ে দাঁড়াবে যদি না দাঁড়ায় কি করে দিবে জল এখানে
আমাকে জানি বাংলা तो और काम और स्टोरी टाइप का चीज़ जो भी है उसको पढ़ना भी यहाँ पे उसको पढ़ना और दूसरा कोई है मतलब एक का पूरा रिस्पॉन्सिबिलिटी पूरा वो पढ़ना ठीक है
জল যদি পড়ে হতে খারাপ হয়ে যাবে
না ওটা শরীর এবারে যখন ওটাকে সামনে আনতা পিছনে তো কোনো ফাটানো যাবে না অ্যাটলিস্ট ওই দুটো মুখ করেও ফাটানো যাবে না আলটিমেটলি যদি
ওদের হাউসকিপিংয়ে ছেড়ে আছে ফোন করে পৌঁছে দেবো অত শুনে
না এটা মাইকটাকে একটু সাইড করে দিতে
না সামনেই ফাটাতে পিছনে তো ফাটাতে
পিছনে ফাটানো যাবে না
সামনেই ফাটাতে সাইডে
আচ্ছা ওরা কি আগে ওপরে উঠবে না আগে নিচে
আগে নিচে
তাহলে আমি নিচে চলে যাই
হ্যাঁ।
এইখানে হ্যাঁ আমি নিজে কি বলবো
এইটা আপনাকে নিয়ে যেতে হবে
হ্যাঁ, আমি নিয়ে যাচ্ছি।
উপরে স্যার আপনার টিকা লাগাবে
হ্যাঁ
দুজন ডাইরেক্টর স্যার আছে আমার আছে টিকা লাগাবে
ওপরে না নিচে লাগাবো
ওদেরকে বলবো নিচে
নিচে
নিচে লাগিয়ে
নিচেই লাগাবে
নিচে লাগিয়ে দিচ্ছি ঠিক আছে
আর যদি কেউ না লাগাবে
হ্যাঁ সে ঠিক আছে
একদম বেশি
একটু ওই আগরবাতি গ্রুপ একটু বলবে একটু করে দিতে
হ্যাঁ, ওটা একটু-
ওইটা আপনিই বলবেন
হ্যাঁ
ঠিক
আচ্ছা
আছে
আর নারকেলগুলো এখানে
নারকেল
রেখে-
ওখানে চারটা আছে
আচ্ছা এখানে চারটে রেখে দিই
এই পিছন দিকটা রেখে দাও
একসঙ্গে রেখে
আমি মনে করি
তো লাল কাপড়টা দিয়ে দাও।
এটাকে সামনে
এখন না এখন এখন
এই প্রদীপটা এখানে চলে
হ্যাঁ ওটা থাকছে
नमामि शमीशाननिर्वाणरूपम् विभुं व्यापकं ब्रह्मवेदस्वरूपम् निजं निर्गुणं निर्विकल्पं निरीहम् चिदाकाशमाकाशवासं भजेऽहम् निराकारमोङ्कारमूलं तुरीयम् गिराज्ञानगोतीतमीशं गिरीशम् करालं महाकालकालं कृपालुम् गुणागारसंसारकारं नतोऽहम् तुषारात्रिसङ्काशगौरं गभीरम् मनोभूतकोटिप्रभाश्रीशरीरम् स्फुरन्मौलिकल्लोलिनी चारुगङ्गा लसद्भालबालेन्दुकण्ठे भुजङ्गा चलत्कुण्डलं भ्रूसुनेत्रं विशालम् प्रसन्नाननं नीलकण्ठं दयालम् मृगाधीशचर्माम्बरं मुण्डमालम् प्रियं शङ्करं सर्वनाथं भजामि प्रचण्डं प्रकृष्टं प्रगल्भं परेशम् अखण्डम् अजं भानुकोटिप्रकाशम् त्रयशूलनिर्मूलनं शूलपाणिम् भजेऽहं भवानीपतिं भावगम्यम् कलातीतकल्याणकल्पान्तकारी सदा सज्जनानन्ददाता पुरारी चिदानन्दसन्दोहमोहापहारी प्रसीद प्रसीद प्रभो मन्मथारी न यावत् उमानाथ पादारविन्दम् भजन्ति ह लोके परे वा नराणाम् न तावत् सुखं शान्ति सन्तापनाशम् प्रसीद प्रभो सर्वभूताधिवासम् न जानामि योगं जपं नैव पूजा न तोऽहं सदा सर्वदा शम्भुतुभ्यम् जराजन्म दुःखो गतातप्यमानम् प्रभो पाहि यापन्नमामीश शम्भो नमामीशमीशाननिर्वाणरूपम् विभुं व्यापकं ब्रह्मवेदस्वरूपम् निजं निर्गुणं निर्विकल्पं निरीहम् चिदाकाशमाकाशवासं भजेऽहम् निराकारमोङ्कारमूलं तुरीयम् गिराज्ञानगोतीतमीशं गिरीशम् करालं महाकालकालं कृपालुम् गुणागारसंसारपारं नतोऽहम् तुषाराद्रिसङ्काशगौरं गभीरम् मनोभूतकोटिप्रभाश्रीशरीरम् स्फुरन्मौलिकल् चलत्कुण्डलं भ्रूसुनेत्रं विशालम् प्रसन्नाननं नीलकण्ठं दयालम् मृगाधीशचर्माम्बरं मुण्डमालम् प्रियं शङ्करं सर्वनाथं भजामि प्रचण्डं प्रकृष्टं प्रगल्भं परेशम् अखण्डम् अजं भानुकोटिप्रकाशम् त्रयशूलनिर्मूलनं शूलपाणिम् भजेऽहं भवानीपतिं भावगम्यम् कलातीतकल्याणकल्पान्तकारी सदा सज्जनानन्ददाता पुरारी चिदानन्दसन्दोहमोहापहारी प्रसीद प्रसीद प्रभो मन्मथारी न यावत् उमानाथ पादारविन्दम् भजन्ति ह लोके परे वा नराणाम् न तावत् सुखं शान्ति सन्तापनाशम् प्रसीद प्रभो सर्वभूताधिवासम् न जानामि योगं जपं नैव पूजा न तोऽहं सदा सर्वदा शम्भुतुभ्यम् जराजन्म दुःखौ गतातप्यमानम् प्रभो पाहि आपन्नमामीश शम्भो नमामीशमीशाननिर्वाणरूपम् विभुं व्यापकं ब्रह्मवेदस्वरूपम् निजं निर्गुणं निर्विकल्पं निरीहम् चिदाकाशमाकाशवासं भजेऽहम् निराकारमोङ्कारमूलं तुरीयम् गिराज्ञानगोतीतमीशं गिरीशम् करालं महाकालकालं कृपालुम् गुणागारसंसारकारं नतोऽहम् तुषाराद्रिसङ्काशगौरं गभीरम् मनोभूतकोटिप्रभाश्रीशरीरम् स्फुरन्मौलिकल्पितकल्पद्रुमम् चलत्कुण्डलं भ्रूसुनेत्रं विशालम् प्रसन्नाननं नीलकण्ठं दयालम् मृगाधीशचर्माम्बरं मुण्डमालम् प्रियं शङ्करं सर्वनाथं भजामि प्रचण्डं प्रकृष्टं प्रगल्भं परेशम् अखण्डम् अजं भानुकोटिप्रकाशम् त्रयशूलनिर्मूलनं शूलपाणिम् भजेऽहं भवानीपतिं भावगम्यम् कलातीतकल्याणकल्पान्तकारी सदा सज्जनानन्ददाता पुरारी चिदानन्दसन्दोहमोहापहारी प्रसीद प्रसीद प्रभो मन्मथारी न यावत् उमानाथ पादारविन्दम् भजन्ति ह लोके परे वा नराणाम् न तावत् सुखं शान्तिसन्तापनाशम् प्रसीद प्रभो सर्वभूताधिवासम् न जानामि योगं जपं नैव पूजाम् न तोऽहं सदा सर्वदा शम्भुतुभ्यम् जराजन्म दुःखो गतातप्यमानम् प्रभो पाहि आपन्नमामीश शम्भो नमामीशमीशान निर्वाणरूपम् विभुं व्यापकं ब्रह्मवेदस्वरूपम् निजं निर्गुणं निर्विकल्पं निरीहम् चिदाकाशमाकाशवासं भजेऽहम्
হ্যাঁ ওটা লাগা। হ্যালো হ্যালো হ্যাঁ দেবপ্রিয় ঠিক আছে, অডিও পাচ্ছি। একটা মাইকটা বন্ধ করে দাও। হ্যাঁ অডিও পাচ্ছি। হ্যাঁ কিন্তু ইকো হচ্ছে, ইকো হচ্ছে মানে কোনো একটা মাইক ধরছে। আমাদের ল্যাপেল মাইকটা
এইটা এখন বন্ধ করে দিলে বলো।
না হ্যালো, না ইকো, হ্যালো হ্যালো হ্যালো, কমাও কমাও, হ্যালো 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 হ্যালো। আচ্ছা এটা নিচ্ছে, ইকো নিচ্ছে।
কোনটা?
এটা ইকো তো হলো না, এটা তো ঠিক হলো।
আমি পেয়েছি। হ্যালো 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 হ্যালো। না কোনো মাইক আরেকটা নিচ্ছে, কটা মাইক আছে। এই যে শোনো আমি বলছি, তাহলে বুঝতে পারবে। হ্যালো 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 হ্যালো। না এটার সঙ্গে কিছু ইয়ে নয় না, একে তো অডিও এরকমই দিচ্ছি আমরা, তো ইউটিউব থেকে দিচ্ছি না আমরা, ওই ক্যামেরা থেকেই তো অডিওটা পাচ্ছে ও, ও তো ক্যামেরা থেকে অডিওটা আসছে।
ইকো হচ্ছে, ইকো হচ্ছে।
হ্যালো হ্যালো হ্যালো। এবার প্লে করো তো এটা, ওইটা হলো পাবো না।
निराकारमूलं तुरीयम्
হ্যালো
हेलो हेलो चेक हेलो
হ্যালো 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 চেক। আর
এর মাইকটা বন্ধ, এর মাইকটা বন্ধ আছে না, এটাই লিখতে মনে হচ্ছে, এটা বন্ধ করি। হ্যালো, না না বন্ধ আছে, বন্ধ আছে, বন্ধ আছে।
হ্যালো,
না না এখানে বললে তো হবে।
আমাদেরটা একটু অফ করে দেবো।
এখানেরটা তো আবার রিভার্বটা এসে রিভার্ব আসছে।
ও মানে স্পিকারটা এ আবার ক্যাচ করছে। হ্যালো, আর লুপ নেই, এখন হচ্ছে আবার লুপ। হ্যালো হ্যালো চেক। হ্যালো হ্যালো। এটা অফ করলেই ঠিক আছে। হ্যালো 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 চেক। হ্যালো হ্যালো চেক। আচ্ছা স্পিকারগুলোর ভলিউমটা লো করে দিলে, স্পিকারের ভলিউমটা লো করে দিন, একদম কম করে দিন। হ্যালো হ্যালো চেক। হ্যালো হ্যালো চেক। হ্যালো, স্পিকারগুলো অফ করে দিলে যখন এটাতে ইউজ হবে। হ্যালো চেক। হ্যালো হ্যালো চেক। হ্যালো 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 চেক। হ্যালো 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 চেক 1 2 3 4 5। হ্যালো Hello, check. Hello. Hello, check. 1 2 3 4 5. Hello. Hello, check. Hello. 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 এটা মানে ব্যাটারি ডাউন আছে জানো আর ব্লিঙ্ক করছে মানে
शुभम मैम ऑफिस में हूँ, मीटिंग में, मैं कॉल करता हूँ। तुम आ जाओ, नैनो नैनो साथी बिल्डिंग में आ जाओ। हाँ 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 हाँ, उसके ऊपर रूम नंबर नहीं है, तुम 4th फ्लोर में लेकर आ जाना, ठीक है।
ज्ञानगोतीतमीशं गिरीशम् करालं महाकालकालं कृपालुं गुणागार संसारपारं नतोऽहम् तुषाराद्रिसङ्काशगौरं गभीरम् मनोभूतकोटिप्रभाश्रीशरीरम् स्फुरन्मौलिकल्लोलिनी चारुगङ्गा लसद्भालबालेन्दुकण्ठे भुजङ्गा।
इस बच्ची का नाम दीपा है। 3 महीने पहले दीपा हमें एक कूड़ेदान में कचरे के साथ मिली। जब हमने इसे स्पर्श किया तब वो रोने लगी और हमें महसूस हुआ ये एक जीवित बच्चा है।
Good morning, sir.
Good morning. Good morning. Can you hear me? Hello. Can you hear me? Hello. Can you hear me?
Sir, am I audible to you, sir?
Yeah, you are audible. Am I audible?
Yes, sir. You're clearly audible, sir. Sir,
Okay.
all will be joining in a second, sir. They are on the way, sir.
No problem. No
Mangal,
problem.
sir, and Ranjana ma'am and director, sir, is coming, sir.
Okay. No problem.
Okay, sir. Okay. Hello.
I am online. I am online. Yes, I can see you. Yes, I can see. Good morning. Good morning.
We were expecting you here, sir.
Yeah, but it I at 3:45 I had to cancel because Raksha Mantri has kept a press conference today. He wanted all secretaries to be present.
Unfortunately, directors, IIT also is joining online, so
Okay.
he will interact through online mode only. We will just go through some rituals. So just our patience, sir. Little patience.
Hmm. Looks impressive.
Kama sir, sound नहीं आ रहा. Sound off कर दिया क्या? Sir, can you hear us?
Yes, I can hear you. Go ahead.
The puja is over. So now the next thing is I will just.
Now your voice has gone. Speak closer. Mic is switched off. Yeah, now it's good.
Yeah. Actually, this is going off. Now I just request you to, before you start, and first start with DGTN. First Madam, then DGTN, then finally you. Just speak a few words. First, before that, I would say, okay. I just would like to mention that I have been here, just for people who don't know, I have been here for last nearly 2 years, a couple of months. And this thing started after, to the best of my knowledge, the activity started here after I joined. And
keep the mic closer to your mouth.
I have made some progress, but we have a long way to go. And all along, I have had great cooperation and blessings, right from Dr. Kamath, the chairman, PGTM, as well as Madam, and various colleagues in IIT Kharagpur, including the Director IIT and Deputy Director IIT. So I am very thankful to all of them to make me or to enable me to come this far. And hopefully after today, it will go a lot further. And DFTM as well as DRDO will support us. I always feel that I still belong to DRDO, but right now I don't. But I must say that there has been a great support from DRDO, and I must thank Dr. Kamath, especially Dr. Kamath, as a friend, as well as a chairman DRDO and secretary R&D. So with that, I just hand over the mic to Madam to say a few words.
Good morning, Secretary Sir, DG Sir, Madam, all the DC Chairman, Chattopadhyay Sir, my colleagues, Das Sir, and I think Director IIT is also online. It's like a privilege for all of us to be here. The seed was born in 2022 when the MOU was exchanged. We were just discussing the history. And thereafter we have come to this stage that we have a very impressive outlay here. A lot of people have contributed. I think all of our predecessors had some ideas. They made it, realized it into certain written policies, then SOPs, and today we are here, that we are looking forward to something good which is happening. In fact, this is one of the most unique concept in the country, I would say, where DRDO industry academia collaboration is being worked out so integratedly in the institutes. There are other centers of excellence, but they don't have any agency like DRDO backing them up in such a wholehearted way that all labs, all our experts are totally supporting this activity. So I think a lot has happened down the line. 2 years after, I think exactly 2 years back, I had taken over from my predecessor. Very impressive kind of projects also are being sanctioned, and we are looking forward that shortly we will get some encouraging results to come out of it. So I think that is all from my side. Very good work by the DIA-CoE team, not just Das sir, the other DIA-CoE team is also there, Deepak Rao and Mr. Sahu has joined recently, I believe. I think the whole team is very charged up and animated under the leadership of Dr. D.K. Das. And of course, our secretary has been really encouraging us. In fact, he has always been traveling to this place, whatever the difficulty it is. Today also he was supposed to be here. And his guidance has really helped us bring the projects to the shape and this kind of infrastructure to this shape. So thank you, sir, for being with us in every endeavor of ours. And thank you entire team who has been supporting us. DG sir has come here in a very early morning. He has traveled and come. I think I thank him also for being here with his total support. So sir, over to you.
Thank you, ma'am. Sir, Chairman DRDO, Dr. Kamal, Director IIT Kharagpur, Dr. Chakravarti, Dr. Das, Director of Center of Excellence here at IIT Kharagpur, Dr. Ranjana, Dr. Varghesh, Professor Chattopadhyay, and our senior colleagues from DRDO, from IIT professors, students, and colleagues. Good morning, and my congratulations for the new building for our Center of Excellence, which is doing cutting edge technology related collaborative projects in the areas of advanced extractive metallurgy, advanced surface engineering technologies, unmanned underwater robotic sensors and actuators, cognitive technologies and cyber physical defense systems, quality, reliability and safety studies, and cryptology and information security. These are some of the thrust verticals which we have created in the Center of Excellence, and we expect many more cutting edge technologies to be developed in these domains. So it is a very big day for us that we have a separate building here so that some focus can be there. And with full cooperation from IIT management and our DRDO chairman, I think this center will flourish with leaps and bounds, and in time to come should become Center of Excellence in whatever verticals we have thought of, so that really some technology related innovations, real IP generation for cutting edge technology can happen, and we can take some leadership role in these technologies. So my best wishes to all here, Dr. Das, that this center will flourish, and my best wishes to all of you on this occasion.
Thank you, sir. If Director IIT is there, can we speak a few words? Sir, are you online? Suman, sir? Probably he has not joined. Has he joined? Okay. Looks like he's probably has not joined. Okay. Sir, Professor Suman sir, can you hear us?
I can hear you. I can hear you.
Sir, I request you to speak a few words about this center. Chairman also is online.
Absolutely. So it's a really great honor. You know, what more would I say? There is a lot of noise coming now. There is a lot of noise. If you could just fix it up there. Maybe you just take half a minute, just fix up the noise, because I know it's very difficult otherwise. Yeah, now it is much better. So first of all, I would start with welcoming our chief guest and our own uh, a little bit. Yeah. Please, if you could mute yes. Yeah. So I would like to welcome our distinguished chief guest, our own pride of IIT Kharagpur, Dr. S.V. Kamath, Chairman of DRDO. Namaskar, Dr. Kamath, and of course we understand your, some last moment, very high level meeting commitment that has come up. We were all looking forward to talk to you physically, but nowadays there is no great difference between interaction so far as physical and online mode comes. So we are equally delighted to host you online.
Thank you.
And also the respected DG Technology Management and Director DFTM DRDO, Dr. Deepak Das, who is the director of this DIA-CoE, which is going to be formally inaugurated today. My dear colleagues and innovators and several young scholars, and I would call everyone as partners of our nation building program. This center has been operating for some time, but with the formal launch of the DIA Center of Excellence at IIT Kharagpur, and that also convergent with our Platinum Jubilee year, we are absolutely delighted that we are having a chance to declare that the future of our national security, it will perhaps no more be inherited, but will be engineered by escalating the activities of not just this unit, but all the centers which are connected and associated. We are entering an era when wars are not being fought at borders. They are fought in bandwidth, in algorithms, in materials, in molecules, and over times, fractions of seconds. The battlefield is no longer linear, it is networked. The adversary is no longer visible, it is adaptive. And superiority is no longer numerical, it is technological. So we have already entered significantly into the era of smart defense, which is not about smarter weapons, it is about smarter systems and a convergence of many technologies. AI that learns from sparse signals, quantum technologies that secure invisible corridors, advanced materials that heal, adapt, and endure, autonomous platforms, and this is one of the major areas where our center has made significant progress. The autonomous platforms that collaborate across air, land, water, space, and cyber. Bio-inspired sensors that detect what conventional systems cannot. And human-machine teaming that augments cognition but not replaces it. Silos are the greatest vulnerability of any R&D system, and integration is perhaps the greatest strength. At IIT Kharagpur, sir, you are quite well aware because you are a very distinguished alumnus. We have spent decades about building depth. And today, through such a center, we must build synthesis. Engineers working with strategists, data scientists with field commanders, material scientists with system architects, and policy thinkers with coders, and possibly students with soldiers. Because the future of soldier must be supported not just by steel and strategy, but by science at its sharpest edge. This center of excellence will not function as a lab alone. It will function as a live, adaptive intelligence ecosystem. We envision rapid translation pipelines from lab discovery to deployable systems. We are trying our best to make our center functional in that way. Secure sandboxes for real-time data-driven simulation and wargaming. Indigenous algorithmic frameworks for strategy autonomy. Trusted sovereign hardware, software tracks, and this is very, very important. All of us are discussing these days. And predictive analytics for anticipatory defense and not reactive response. So from make in India to think in India to lead from India, I think defense and space are the two critical foundations where our technological dependence is strategic dependence, and strategic autonomy demands scientific audacity. Let us also recognize a deeper transformation underway. Defense innovation can no longer afford long gestation cycles detached from operational realities, nor can academia remain insulated from national imperatives. So this center is truly to be a bridge, but more than that, a fusion point. Here, classified insight will meet open-ended inquiry. Operational urgency will meet fundamental science. This is where institutions of national importance, academic institutions, should take a lead. And national security will meet national intellect. Our students will understand that patriotism in the 21st century is not just sentiment. It is to build up a competence, it is excellence, and it is ethical technological leadership as a true patriot. So smart defense is not about escalation. It is about deterrence through intelligence, stability through capability, and peace through preparedness. When technologies converge intelligently, the deterrence becomes decisive. I thought that if physically we could get an opportunity, I would perhaps spend a few words about some quick thoughts on IIT Kharagpur's expectations from DRDO, possibly around this center and beyond. But nevertheless, since sir you are online, I would like to summarize. So we would like to escalate our level of engagement from what we have to mission mode engagement rather than fragmented project-based interactions. When problems are defined at the systems level with clear operational context and performance targets, our faculty can align research towards deployable outcomes. Long horizon, multi-phase programs, this can enable deeper technological maturity than short cycle usual project grants. Number two, the speed and clarity in the decision making may be very significant. Our faculty are definitely enthusiastic, students are energetic, and labs are active. And we have, I believe, several proposals, more than 10, around specifically 13, so far, according to my understanding, under consideration. I would request that if a mechanism be set up so that moves swiftly through evaluation and approval so that the momentum is sustained. Third, we would welcome co-development frameworks with shared milestones, joint steering committees, and embedded DRDO scientists within our IIT Kharagpur research cluster. I would like to have more and more DRDO scientists embedded within our research cluster, not as external people. Physical and intellectual collocation like that may accelerate translation from concept to prototype to field validation in the way in which it will be useful for DRDO for deployment. Also, we seek some support for high-end infrastructure that can serve as national assets. Our young colleague, Professor Chandrasekhar Tiwari, has developed a very unique proposal on advanced additive manufacturing systems using the circular manufacturing. That means there are many defense products which have a limited lifespan, and those materials can be then fed into the additive manufacturing pipeline to make them productive for many items. Professor Tiwari has a detailed proposal, and I would request you to have a look into it if that is emailed to you, from the institute. Also, high temperature materials testing facilities, secure AI computing clusters, underwater test beds, specialized battery research platforms. And these can function as shared facilities for DRDO programs across the labs. We do not want these to be just properties for IIT Kharagpur's individual sake. It should be collective national property, but we can host them and facilitate like a hub. We would also like IIT Kharagpur to assume leadership roles in select thrust areas aligned with the national defense priorities, just like the circular additive manufacturing I mentioned, advanced batteries for autonomous systems, cyber security and hardware security, healthcare technologies for defense personnel in extreme environment. This is where IIT Kharagpur, you are very much well aware that we are the first to start the School of Medical Science and Technology. 25 years back, the then President Dr. Abdul Kalam facilitated, and also the pride of DRDO, I would say. And from then till now, we have advanced significantly in healthcare technologies to an extent that many of those can be directly adapted for use of defense personnel in extreme environments. So that also IIT Kharagpur can give some leadership, and specialized AI ML frameworks for defense decision support. In this way, our leadership can actually implicate accountability, scale, and continuity. And in that way, we envision a long-term compact between DRDO and IIT Kharagpur, one that transcends individual projects and possibly builds enduring capability in a sovereign framework. Our aspiration is not merely to execute funded tasks, that anyway we will be very, very honored to do, but to co-create technologies that redefine operational readiness and strategic independence. If we align research excellence with national urgency and academic creativity with such mission clarity, where DRDO has its own missions and we can align to the best of our capabilities, we will definitely not just build products or some kind of reports, but platforms of resilience for India's defense ecosystem. India definitely stands at a civilizational inflection point. As a nation that gave the world both philosophical depth and mathematical precision, we are stepping forward to lead the technology world. The DIA-CoE at IIT Kharagpur will not therefore chase trends. We expect that with your kind guidance and leadership, we should set paradigms. We should cultivate leaders who can think across domains relevant to research, defense specific applications, design across scales, and decide under uncertainty. This is the age of convergent technologies. It is integrative, it is anticipatory and courageous. So today, as you are going to formally inaugurate this center, it is not merely opening the doors, it is to open the possibilities. To our citizens, armed forces, strategic partners, we believe that through this center in our Platinum Jubilee year, India will not be a passive consumer of security architectures. We will architect them. Let this center be a crucible where science will literally meet strategy, intellect will meet integrity, and innovation will work exclusively for national purpose. The future of defense will be smart, convergent, with many such technologies, and we are all proud to think that with your leadership, the future of defense will be fully Indian. We look forward to your guidance, Dr. Kamath, as we move from inauguration to implementation, from intent to impact. Thank you. Namaskar. Jai Hind.
request Chairman DRDO and Secretary DDR&D to say a few words.
Am I audible?
Yes, yes.
Okay. Professor Suman Chakravarti, Director, IIT Kharagpur, Dr. Mangal, Dr. Ranjana, Dr. Das, Dr. Abraham Varghese, all the professors who are gathered there, my DRDO colleagues and staff of DRDO Industry Academia Center of Excellence at IIT Kharagpur. A very good morning to all of you, and I apologize for cancelling my visit at the last moment, but that was beyond my control, as Honorable Raksha Mantri has fixed up a press conference today where he wanted all the secretaries in the Ministry of Defense to be present in that conference. So at the outset, let me congratulate DRDO Industry Academia Center of Excellence at IIT Kharagpur for their new office. And I am fully in consonance with the thoughts expressed by Professor Chakravarti with respect to the importance of this center for setting the requirements of the defense R&D needs of the country. As Professor Chakravarti very eloquently stated, the nature of warfare is changing. The role of technology a few years back, we had a clear vision that the R&D should be top down in the sense that what are the nation's needs should be addressed through these centers of excellence. And although a lot of good work was happening in academia, it was rarely getting translated into a final product. So we felt that these centers can act as a catalyst to transition a lot of the good work which was happening in academia in collaboration with DRDO labs and industry. How quickly could we translate those good R&D work into technologies and products which our services could use? We have had some teething issues in the sense that the sanctioning process is currently taking too long. And I agree with Professor Chakravarti that we have to find mechanisms to speed it up. And I'm sure DGTM and Director DFTM are working on mechanisms to speed this up. We have set ourselves a target that most projects should get sanctioned in 3 months and the outer limit should be 6 months. I'm sure they will work out mechanisms to ensure that this happens in the future. I think you have listed out quite a good number of technologies that we need to look at if we have to achieve leadership. There are others also like photonics, semiconductor technologies, quantum technologies, of course, you mentioned, but these are emerging technologies which we have to achieve leadership. And that can be done only if we work together. So this is just a start. I think the last 2-3 years where the center has been operating since 22 or 23. And I'm sure with all the teething issues resolved, we will be able to move to our goal of delivering cutting edge technologies and products to our services. So my best wishes to the center, and I'm sure if we have a chance to meet again in 5 or 10 years, we will see a different India delivering and leading in several critical defense technologies. Thank you very much and wish you all the best.
Thank you, sir.
Thank you, sir, and we will be looking forward to physically hosting you at the institute. We know that your position is such that at any point of time, at the highest level, you are called. But I think that we will get an opportunity again soon
Sure.
to invite you, and in particular deliberate on some of the important technological areas where IIT Kharagpur can work more closely with DRDO. Given an opportunity, I can also go and meet you at your office physically,
Sure.
and then we can discuss and take it forward.
You're
Thank you, sir, very, very much. And I would request Dr. Das to continue with the proceedings.
Thank you,
Thank you,
Professor.
sir. As far as proceedings are concerned, I mean, for online purposes, I think it comes to an end here. I will just take these people who are gathered here around the center. So that probably you can't see through online. So I will request Dr. Kamath to just be there for under 2-3 minutes. I just will join in online for a presentation of one of the IT programs that they wish to propose. So quickly, I'll just come back to you. Did you hear Dr. Kamath?
Yeah, please go ahead. I'll be waiting.
In another 2 to 3 minutes, I'll come back.
No issue at all. Please go ahead.
So I'll just take people. Okay, so we'll just have a look at this. This is our meeting. Probably you can show online also. This is basically for various meetings, and we have all the facilities built in here. So this is one of the rooms which took some time to think about designing and doing it. So the the vendor has done a good job. So this is where the center director is supposed to sit. So you can just have a look. IIT has given a fairly big space, so this is the end. Some more rooms have to be prepared, so we have prepared this that side. We have to more rooms, and we have done for one for visitor. So you can, and here one room we are giving to one project PI for setting up his workstation and things like that. So maths department doesn't have much space. We have to set up his workstation. Department. Oh, you are here now. Just welcome. These are some of the rooms where we sit. Some of my staff will sit in one of the rooms. I'll just show you around there. is the visitor room we have made for visitors to wait. So this is room, and this is a small kitchen also here. Some small kitchenette kind of thing we have made. So this is all for the time being, but there are some rooms to be made still. Okay, we ask Madam some afterwards. Yeah, we will get that. So, we'll just have a cup of coffee now, and then we'll join the chairman for presentation. I had a presentation. Just quickly, actually we can have the meeting, and then you can just continue with the. Room back. I request you to start.
Sir, can you hear us?
Yes, yes, yes.
Okay, Chairman sir, I think you are on mute.
Yeah, I can hear you. Sorry.
Yeah. So, on this slide, no. Sir, can you hear us now?
Yes, I can hear you.
Okay. Dr. Chandrasekhar Tiwari, professor in IIT, so he will just go through a small few slide presentation just to express his ideas and just for your guidance because IIT would like to.
ठीक है।
हेलो हेलो हेलो। hello.
लोग को बुलाएंगे तो माइक कैसे सब लोग को बुलाएंगे जब माइक क्या करेंगे? हेलो टेस्टिंग हेलो हेलो सर हेलो 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 सर can you hear me? No, I don't think so. Hello. Yes. Sir, can you hear me, sir? Okay. Sir, I think your system is on mute. Volume, can you increase the volume, sir? Good morning to all distinguished guests, respected dignitaries, eminent speaker, faculty members, researcher, and dear students. With great pleasure and pride, we have just completed the successful inaugurations of the DRDO Industry Academia Center of Excellence. Through this center, we have to facilitate the collaborative development of critical technologies for DRDO by utilizing the excellence or expertise available at IIT Kharagpur and other academic institutions for years to come. It is a great honor for all of us at the COE to be part of these special occasions, and we sincerely thank our respected chief guest and all the distinguished dignitaries for being with us today. Now, moving ahead with today's program, we will now begin with our seminar on advancement in technologies for unmanned underwater vehicle and future trends. This seminar has been arranged as a part of the research vertical Unmanned Underwater Robotics, Sensor and Actuators under DIA-CoE IIT Kharagpur. It is my proud privilege to invite our chief guest, Dr. Samir V. Kamath, Secretary, Department of Defense R&D and Chairman, DRDO, to deliver the inaugural address. Sir, we are deeply honored by your presence. Sir, may I request you please say some words to our gathering.
Director IIT Kharagpur, Professor Suman Chakravarti, Director General Technology Management, Mr. Mangal, Director DFTM, Dr. Ranjana, Director DIA-CoE IIT Kharagpur, Dr. Deepak Das, Director NSTL, Dr. Abraham Verghese, all other dignitaries present in the audience, ladies and gentlemen. A very good morning to you. And at the outset, let me apologize for not being present physically there. Due to some pressing commitments, I had to cancel my visit at the last moment. I would like to start by congratulating DIA-CoE for organizing such a conference or seminar on a very critical topic for defense for defense R&D in the country. I think the importance of unmanned aerial vehicles in warfare has been aptly demonstrated in the recent wars. And whenever we have a next naval fight, the importance of underwater autonomous vehicles or unmanned underwater vehicles is going to play an equally important role. So it is very critical that we look at all the technologies which are associated with unmanned underwater vehicles and ensure that these technologies are developed within the country and put these technologies are utilized in the next generation UUVs that we deliver to our services. As you are aware, unmanned underwater vehicles utilize a complex ecosystem of technologies to overcome the challenges of high pressure, low visibility, and limited connectivity in the deep sea. Some of the key technologies which we need to work on are navigation and positioning. Unlike aerial vehicles, navigation and positioning in underwater domain is much more challenging. So we have to look at INS systems, the Doppler velocity logs, acoustic positioning using acoustic beacons for correction of the errors which develop in INS systems. We have to look at technologies for autonomy and control, which should definitely include AI for path planning. We have to look at technologies for multi-sensor data fusion. We have to look at technologies for both power and propulsion. So we have to look at higher energy batteries than the present ones. We have to see how we can use hydrogen-based fuel cells and AIPs for powering the next generation UUVs. We also have to look at how we can utilize the underwater waves and other resources underwater for underwater charging so that the missions can be extended without these vehicles having to surface. We have to work on underwater communication technologies. As you are aware, RF does not work underwater. Acoustic communication also has its limitations in terms of range. So we have to look at newer technologies which will allow us to communicate for much longer distances and also with much higher data transfer rates. We will have to look at sensing and imaging, advanced sonars such as side scan sonars, multi-beam sonars, LIDARs and computer vision systems for high resolution seabed mapping, target detection and collision avoidance. In future, we will also have to look at swarming technologies very carefully. I think the swarming technologies now are pretty much standard for aerial vehicles, but for underwater vehicles, these technologies have to be looked at because of the limited communication ability at present. Swarming is still a challenge underwater, but we will have to address these challenges ahead. I'm sure this conference will provide a good platform for all the researchers who are gathered here today to address some of these issues. And I'm assuring you that if you have good ideas, we will use the DRDO, DIA Industry Academia Centers of Excellence for pushing some of these projects. So my best wishes to all of you who are gathered here today and wish you very successful deliberations throughout the day. Thank you. Thank you for your kind attention.
Thank you very much, sir, for your visionary and motivating address. Now, at the outset,
I will seek permission to log off as I have to go for the Raksha Mantri's press conference.
Sure.
Thank you.
Thank you, sir. Thank you so much, sir.
Thank you.
At the outset, I invite Dr. Deepak Kumar Das, Director, DIA-CoE, IIT Kharagpur, to deliver the welcome address. Sir, please come on the dais and address to our audience.
Chief guest Dr. Samir V. Kamath, Secretary, Department of Defense R&D and Chairman DRDO, Professor Suman Chakravarti, Director IIT Kharagpur, Sri L.C. Mangal, Director General Technology Management DRDO, Professor Intu Banerjee, of course, is probably not present here, Deputy Director IIT Kharagpur, Dr. N. Ranjana, Director DFTM DRDO, Dr. Abraham Varghese, Director NSTL, Deans, other professors of IIT Kharagpur, ex-DRDO experts and technical expert committee members, other DRDO dignitaries and scientists present here, students, research scholars, ladies and gentlemen. Good morning to you all. I express my heartfelt appreciation to all of you for taking time out of your busy schedule to join us in the inauguration of DRDO Industry Academia Center of Excellence, that is DIA-CoE, IIT Kharagpur, as well as the one-day seminar that is currently going on. It gives me great pleasure to welcome you all to this seminar titled Advancements in Technologies for Unmanned Underwater Vehicles and Future Trends. As you may know, despite the oceans covering more than 70% of our planet, they remain among the least explored frontiers. However, in recent years, exploration of underwater domain has been increasing rapidly. In this context, use of underwater vehicles is rapidly transforming maritime security, ocean science, and strategic capabilities. Since the future battlefield, as well as the blue economy, would increasingly extend beneath the waves, nations that master the underwater related technologies will possess a decisive advantage. Therefore, for a maritime nation like India, these technologies are central to our security, economic prosperity, and technological advancement. Underwater vehicles, which include remotely operated vehicles or ROVs, autonomous underwater vehicles or AUVs or AUUVs as they are called, they have emerged as force multipliers over a period of time. They enable surveillance, mine countermeasures, anti-submarine warfare support, seabed mapping, and search and rescue operations. For India, these technologies are not merely scientific curiosities, these are strategic necessities for safeguarding our vast coastline as well as offshore and undersea assets. One of the greatest challenges in underwater technology, which Chairman a little earlier alluded to, lies in the environment itself. Unlike air or space, seawater is dense, corrosive, opaque to electromagnetic waves, and highly variable in nature. Therefore, issues related to navigation without GPS, reliable long-range communication, stealthy propulsion, biofouling, efficient energy management, and robust autonomy pose serious challenges. Yet, these challenges have been driving innovations over the years, especially in recent times in areas such as AI-enabled autonomy, swarm operations, underwater acoustic networks, advanced high-endurance batteries, and so on. The contributions of DRDO have been both significant and forward-looking in most areas related to underwater vehicles. DRDO labs such as NSTL, Visakhapatnam, NPOL, Kochi, and NMRL, Ambernath have been playing pioneering roles, be it underwater propulsion, hydrodynamics or sonar systems, navigation, communication, or specialized materials for underwater platforms. Even beyond DRDO, underwater R&D ecosystem exists in organizations such as National Institute of Ocean Technology, that is NIOT, and academic and non-academic institutions, including IIT Kharagpur, IIT Madras, CSI, CMERI, Durgapur, to name a few. Indian industries are also increasingly showing interest in these technologies. Apart from in-house R&D, DRDO has been utilizing the expertise and experience available in academia through funded projects and programs for developing technologies for underwater applications. One of the mechanisms through which this is being done is through DIA-CoEs at various institutes such as IIT Kharagpur under the aegis of Directorate of Future Technology Management, that is DFTM DRDO, which is a DRDO body. This is driving deeper collaboration between defense laboratories, academia, startups, industry, and relevant users for developing cutting-edge technologies for DRDO. Research proposals in underwater area are being considered at DIA-CoE IIT Kharagpur under the technology vertical which was mentioned earlier, that is unmanned underwater robotic sensors and actuators. One of the purpose of having this seminar is to spread the news basically about this DIA-CoE as well as this particular vertical among the faculty and other researchers and encourage them to take advantage of the research opportunities available. The second purpose, of course, is to highlight the important technology areas in underwater domain that are relevant to DRDO, as well as their current status and future directions. I hope these will be brought out lucidly during the various presentations that will be given here. I am sure the deliberations in today's seminar would provide a good platform to exchange ideas, identify gaps, forge partnerships, and help strengthening India's underwater technology capabilities. In conclusion, I once again welcome you all the participants to this seminar. Thank you. Jai Hind.
Thank you, sir. Thank you for your warm and inspiring welcome. I now invite Dr. N. Ranjana, Director, DFTM, DRDO, to kindly address the gathering. Madam, I request you, please come on the dais and share what.
Good morning once again. Director IIT Kharagpur, Professor Suman Chakravarti, DGTM sir, Dr. Das, Abraham Varghese, my colleague from NSTL, my colleagues from DRDO headquarters, Chairman of TEC, Prince Joseph sir, and Chattopadhyay sir, and other colleagues whom we have worked very closely in advancing the technologies. At some stage or the other, we have been working together, all of us who are sitting here. Very long association with Chattopadhyay sir, some brief association with sir also, with Abraham, of course, in NSTL. And now we are trying to expand our footprints. So we want more partners in our technology goals, and that is why this academic partnership concept is proliferating much bigger, much wider, and all hands that are there on the decks are required to help us make the technology that we are trying to do. And I think all of us have certain strengths, certain experiences, and certain ambitions that we want to nurture. And in this way, the collaboration has to be such that it's a win-win situation for all of us, but technology being at the supreme, that we should be able to achieve the technological breakthroughs that we are embarking on. So DIA-CoE is one such concept where the DRDO industry academia has been mandated to work together to bring out little higher TRLs. DRDO has been working with academia for so long through research boards and extramural research. IIT Kharagpur has a very long history of many projects through these schemes. And we have been doing this together under very lower TRLs. Some of them have become good TRLs also. But DIA-CoEs primarily have been brought to bring out TRL 2+, I would say TRL 3 to 5. and as much as possible with a particular prototype or a product or a kind of a proof of concept in a visible form to be developed. Number one. Number two, the multi-institute, multidisciplinary, researchers concept has been also enabled, where see, no product can be made which is having only one science or a one subject. You require multiple expertise, multiple sciences to bring it together, and that is why DIA-CoE encourages multiple academic partners, multiple academic institutes, industries to come on board to make it possible. This is the second premise. The third premise, I explained it elsewhere, that it's not just the verticals that we are today talking about in DIA-CoE Kharagpur. You are welcome to take up projects in all other verticals which are available. Dr. Das has been doing this yeoman's job of formally forwarding these proposals to the right places. In fact, we are giving all our problem statements to him so that he can circulate in the academia. We have, DRDO has on today given 35 active problem statements, which are really challenging problem statements which we want to solve. DRDO labs have defined themselves with the figures of merit. They are being shared. They are not on the public space as of now. We are trying to see whether we can make the necessary approvals. Some of them are on the website. Some of them are circulated to these DIA-CoE directors to one-on-one find out if any expertise exists which can be married to with your research interest. So there are all kind of possibilities existing today that we are trying to accelerate this work through the DIA-CoEs. Now, importance of technologies has been brought out by Secretary Sir very lucidly, and of course Dr. Das has brought out what are the technologies, looking at it, and today's vertical on advancements in technologies for underwater unmanned vehicles is very unique. In fact, we always like when we have very small gathering with more focused debate and the conversation with each other, so that we can work in detail or discuss in detail and debate in detail. And this is promoting the culture of brainstorming to bring out the problem statements to a very concrete form earlier than later. So that is why these kind of workshops and brainstormings are in not a very vast setting of conferences where hundreds of people are there, but they are in a very focused setting that we are trying to see that end of this workshop at least one or two detailed problem statements will come out in the given areas that we have chosen to. So this is the importance of this kind of workshops that we have been organizing at every center, and on very, very advanced topics where nobody is touching such topics. Now, I'll not go into that. My lot of good projects have already been started in last 1 year at IIT Kharagpur through DIA-CoE. Some projects are ongoing which were also inherited through JCB, and all of them are promised that they will give out a particular product or a result. My request to the entire research fraternity is that we have to look at the end in sight and then work backwards at what we are going to do to actually reach that goal. There has been an exploratory research, an idea comes, you explore it, experiment it and find it, but that has already been a very good practice. India is in top 5 of the 50 technology out of 75 which ASPI is tracking. We are the most published nation, most referred papers are there, impact factors are high. We are very, very established in the research domain. The thing today is required is convert it into the real stuff and technology so that people can convert it into a technology advantage for the country. So for that, we are requesting all the thought processes to also involve industry into the area that we are trying to make it. If we are not able to do it, we can work with industry, we can allow industry also to, they have good manufacturing expertise, they have experience also in manufacturing certain things. We have made bench tops, we have made prototypes, we have to marry it in such a way and understand each other, know how, know why, so that they can make the next versions also, next prototypes also, and can think of commercialization. We all do not have all the expertise. as scientists, as researchers, we may not have commercial mindset or the entrepreneur mindset. We have to use industry for that. The manufacturing expertise also exists there. So we have to use the industry for its strength. We have to give our strengths. So if it is not realized today, it goes waste. Some other country does it better than you, before you. So it's onus on us that as fast as possible, we should be able to convert these technologies into the real products, either as a supply chain, as a component, or as a system. Whatever you feel appropriate, where is the end goal of your project, should fructify into something useful. So this has been the goal. The problems which were discussed at the center, the timelines, we are aggressively trying to see how we can shorten it. Certain things, if we do very well from the starting, if our project proposal is well formulated, it is well discussed, and work share of the lab, industry, academia is worked out in advance, we can assure you within 2 weeks, 2 months, we will be able to give you the project sanction. And once the sanction is there, you don't need to wait for the money, you can start your procedures. That has also been said. So having laid down so much of a grounds for this thing, now I think time will be there in next 2 to 3 years. We are trying to see whether what best we can give it back to the nation with this kind of an investment. What can go, you can feel proud of what has gone into an underwater system which is being trial run at NSTL, and that has been done by a professor or a student. I think we want to create that kind of a happiness among the entire ecosystem. The ecosystem is something that we are trying to energize with respect to the defense technologies. A lot is happening, you know, at every sector. Armed forces are doing their bit. DRDO is doing their bit. Researchers are doing their bit. We have to make sure that we really fructify the entire efforts into something which is very, very useful for all of us. And this will give us a foundation for reach the cutting edge. I am not saying we will reach cutting edge in the first tranche, but at least we should have laid down the foundation that the next tranche will be the cutting edge. We have to do, and other than this underwater systems that we are talking today, the cyber security is one of the field that we try to energize this center with. And certain other technologies also are being aggressively pursued. So my request to the entire research community is, if the proposal is well formed and well thought of from the starting, and I think the technical evaluation teams are there, and my sincere thanks to all the chairmen of the TCs who are been really helping us. Sometimes not just evaluation and feasibility, they are also helping us improve the proposals very effectively. And we often meet them online. Today, happy to see them in person and being able to get their guidance. So we want all hands on the deck to help us take this initiative to a very useful conclusion. So I wish the workshop very best, and I'm sure something concrete can be coming out as a part of this deliberation. Thank you so much, and thank you DIA-CoE team for Dr. Das to organize this, and congratulations to entire fraternity for such a beautiful center that we have seen today. Congratulations to everyone. Thank you.
Thank you, ma'am, for your enlightening words. May I now request Sri L.C. Mangal, Director General Technology Management, DGTM, DRDO, to share the valuable thought to us. Sir, please come.
Good morning. Professor Chakravarti, Director IIT Kharagpur, Dr. Ranjana, Dr. Abram Vargheese, Dr. Das, senior professors, students, and DRDO colleagues. The topic of advancements in underwater vehicles technologies is very relevant. It is a transformative and disruptive technology domain, which is basically still having low TRL in terms of critical technologies if we look at. And therefore, it is a very important area where a lot of research and patents we can create. New technology related modules can be developed. And really in this domain, not only for our India's self-reliance in defense technology, but also being a dual use, lot of exploration in civil applications in the ocean are also possible with this technology. Therefore, we can get a leadership role both in civilian as well as military applications if we really pursue this domain with vigor and sustained efforts. So the technologies which are identified, I think already a lot of technologies have been listed by our chairman, and also they were supplemented by what Dr. Das mentioned. The technologies which are relevant for military is stealth in nature. Basically, we want the operations to be undetected. Therefore, there is a special requirement that we develop technology which are, if it is communication, then low observable. If it is propulsion, then low noise, which is not creating any acoustic effect, so that the detection becomes very, very difficult through sonars. Advanced sonar also should not be able to detect them. Then the advancement in the navigation, because as we know, GPS systems and things like that cannot be used there. Therefore, all applications of quantum sensing for navigation purpose is a very important topic for underwater vehicles. And advanced communication technology. Acoustic modems have been there for last quite many years, but throughput and increase is also reaching the limit. What is required is a hybrid approach to the communication, where you can integrate the acoustic medium along with the optical and in some cases RF. So these are the three domains where integrated technology is required to be pursued for advancement in the communication and networking for underwater applications. And how you team up that underwater vehicle with a subsurface vehicle or a submarine, manned submarine. So these are advancements in the networking and communication technology which definitely require a push. And I think there is a common technology which is available in the optical domain, which already a lot of maturity is happening in the airborne communication. However, because of the peculiar effects of the channel in the underwater, a lot of signal processing related innovations have to be done for underwater laser communication or optical communication if we want to use it for our useful operational scenarios. So these are various applications where technology have to be pursued, autonomous systems teaming with surface vehicles and manned systems, and the important domain of multi-domain operations of these drones. What is required is reconfigurable drones which initially could be sitting inside water or floating in the water, but suddenly if mission demands, they can take a different domain like ground domain or an airborne domain automatically depending on the mission profile. Such kind of capability is being experimented across the world, and I think this is where some standardization of components, the technologies of propulsion, the technologies of communication, the technologies of batteries can be standardized, and we can reuse them across the multiple domains. Whatever is maturity happening in the airborne domain or in the ground domain, if they can be customized for our underwater applications, let us use them. Why to do a reinventing of the wheel? Similarly, if any innovative technology we have carried out in the underwater domain, why can't we apply it for the other domain operations also? So a common set of technologies we can create for multi-domain operations for all types of applications of drones, where underwater becomes a one specialized subject because of its peculiar nature. And this is where innovation of multidisciplinary nature comes into picture. And there is no better place than IITs, which are multidisciplinary by definition. Today I came to know that there are 60 departments in IIT Kharagpur and 900 faculty is there. So it is a unmatchable human resource which is available in the single institute under one umbrella.
why can't we take up some cutting edge multidisciplinary technology development projects? Underwater is one multidisciplinary area, that it is not just one problem to be solved. All types of engineers are required to collaborate. Fundamental science related problems have to be solved if we have to really perfect the system and create a leadership role. So it is required that you identify, I will request my naval research laboratories like NSTL, NPOL, NMRL, and also material research labs to come out with some multidisciplinary topics, challenging topics which are unique, throw them to IIT system and let them take up the complete system development within one IIT itself. Why to go for different IITs? Because it is a multidisciplinary organization, therefore best talent is available here and they have an advantage of complete networking across the world. Whatever best is available with the various foreign universities, they know it because the research brings out that aspect where what is happening. So they have full technology spectrum, scanned very periodically, very fast. I think they must be having some digital database also now. Many things are available. So let us utilize that digital database of technologies, awareness, what is available. Within IITs, multidisciplinary thesis must be created, PhDs and all MTechs. Let us utilize those topics, and DRDO can provide you specific topics on which you can award PhDs. Multidisciplinary PhD topics we can give, where some really technology development can happen. Recently we came to know that China has adopted a PhD through technology product. Rather than doing a paper research, if you can develop a technology or a product, they will award PhDs. Why can't we do similar kind of things for us? So DRDO can definitely look into throwing some technology related challenges which have a potential for research, therefore you can do a PhD. And in that framework, we will definitely support funding for prototyping. Not only the scholarship, which of course HRD will take care, but the funding part for the prototype development we can definitely support. So these are areas where I think we should work together, work out some cutting edge proposals, topics where our laboratories can define, and then you can fine tune the research problem and then launch them. In parallel, we can launch those multidisciplinary projects. Then in the last 5 to 7 years, I think a lot of patenting must have happened in IITs. A lot of patents come out of the basic research, whatever we do. And many of those patents are convertible into technology or products. So we can identify those patents and we can definitely think of patent to technology or patent to product kind of projects. And let us work together. Our laboratories can help in giving the proposals where such patents, if you can share those patent related information with our scientists, I think we can identify which can be a potential candidate for technology, and accordingly funding can start. So these are different types of methods which we want to basically start for engaging and utilizing our expert knowledge base which is available in IITs, and then the incubation centers which you have got. Huge incubation related infrastructure is there in every IIT, and therefore a lot of startups have come up. You are already mentoring them, you are funding them. So we want to utilize that platform with our DIA-CoEs. We want to link them together. We want to leverage this DIA-CoE center as a catalyst for this growth in technology, where already the complete infrastructure is available in each IIT. So why don't we use that? I would request Professor Chakravarti to help us in identifying, sir, your method, how to engage. You might be having some experience. Let us use this platform of DIA-CoEs to come out as a center of excellence like MIT Lincoln, or you can see that Joint Propulsion Laboratories. These are center of excellence in US, where the full technology related product development is done by the academia and with full funding from industry and government. So same model we can develop here, and really the complete ecosystem whatever is available for startups, and we will encourage professors owning the startups. So we want to launch one scheme where academic entrepreneur kind of concept we want to take, where we will award the projects to those professors who are having the startups. so that the technology risk which is there, which startup faces, can be solved by the professors themselves, and they can team up with their other professors to come out with cutting edge technology related innovations. So these are some of the ideas, sir, we want to try and fine tune them. Of course, they are very sketchy ideas which we want to basically make meaningful, and meaningful in terms of not only realization but also sanction process, because we know that government has got peculiar rules and procedures where something can come in our way. So we need to find some innovative methods also to solve the finance related bottlenecks which could be there. But I am sure that with little maneuvering, those problems can be solved. Only thing is will is required. We have to collectively work together. It is a transformative era where our Honorable Prime Minister has given a call that let us accelerate the technology pace so that in many of the fields leadership position can be attained. And fund is never a money problem. You might be aware that we can fund projects directly to startups, to the small scale industries, up to the tune of theoretically 50 crore. Of course, startups being very new, we cannot take that type of challenge of awarding single project of 50 crore. But certainly 5-10 crore project definitely can be given to the very, very new startups. If startups have established, yes, we will take a risk of even giving them large money projects also. But there are many other methods. Academia can tie up with startups, so we can create a collaborative team. So professors, energetic professors who are young, who have done a recent PhD in the cutting edge deep tech domain, can come out with proposal where he wants to utilize his patent, whatever technology he has realized. Let him suggest us in what way he wants to take this project, so that in 2 years or 2.5 years time frame we can really bring one of the first technology in the world. So these are some of the initiatives that we want to launch. I want to basically create some framework. Of course, some guidelines we have created already, but we want to mature them, and in next 2 to 3 months we want to launch them in a very comprehensive way. So I wish that this particular topic brings out a list of critical technologies, whatever workshop, at the end of workshop, with the help of our NSTL and other laboratories, along with professors, let us bring out the technology readiness level which is there for this technology domain of underwater thing in India, and accordingly prioritize those technology developments through academia and startup together. We can definitely, if we get that recommended list, certainly we will launch certain focused program for development of these technologies. And also similarly, other verticals where this DIA-CoE has been created, in those domains also such cutting edge technology related innovations we can launch, provided there is some groundwork which is happening with right combination of our laboratories as well as academia. So I call upon every startup, every postdocs, all PhD students to innovate, to create technologies through collaboration, and you suggest me the collaborative model. We will work on that collaborative model, how to tweak it so that it can be implemented and processed. So with this, I wish all the best for our Director DIA-CoE, the initiative, the IIT Kharagpur management, and also the students to work in this area. It is a multi-disciplinary dual-use application, tremendous growth for industry. Civil industry will also get benefited with whatever technology you develop, not only our military. Therefore, we will support every idea, because we are mandated to support any technology development which has either military application or dual-use applications. So with that in background, I think you can take up full throttle development. Only it is the initiative which is limiting us. Therefore, otherwise resource-wise we don't find any problem. We have, I will say, theoretically infinite money. If you take me like that there is no dearth of money which is available, and therefore it is only the initiative and imagination which will make us to the top, and not the resource constraint which can limit us. So I thank you very much for giving me this opportunity, and I wish that this center of excellence works and creates leaps and bounds performance in the time to come. Thank you.
Thank you, sir, for your insightful address. It is now my privilege to invite Professor Suman Chakrabarti, Director IIT Kharagpur, to address the gathering and provide IIT Kharagpur perspectives. Sir, may I request you please come on the dais.
Good morning, the distinguished guests. Dr. Kamath, I think, is out for his meeting. But having said that, we have the distinguished scientists from DRDO and DFTM and the respective leaders. And thanks for your deliberation. And we echo your feelings, and I will share with you our combined vision to take this forward. Also, I welcome our esteemed colleagues, officers, faculty members, researchers, students, industry partners, and Dr. Deepak Das, who is heading this very, very important Center of Excellence. It is a privilege to address this particular seminar on advancements in technologies for unmanned underwater vehicles and the future trends. I will share two different aspects combined here. One, a bit about the theme of the seminar and how the institute has been very active in this area, but also broadly on the expanded domain of activities that the respective chiefs of the units have just now shared. Today, we are not merely discussing about underwater vehicles. This is something which has been discussed over the years, and it continues to be a very, very important topic, but we are in a focused manner reflecting on the strategic autonomy beneath the water, beneath the ocean. We are speaking about the technologies that do not announce themselves but profoundly define national power. And the underwater domain is perhaps the last great strategic frontier. Opaque, unforgiving, nonlinear, and extraordinarily complex. There is no GPS guidance. Communication is limited, unreliable. Pressure is extreme. Corrosion is relentless. Turbulence is unpredictable. And yet, this is precisely where the future of maritime security and strategic advantage increasingly resides. So, unmanned water vehicles, these are not simple mechanical constructs. These are force multipliers, risk reducers, intelligence gatherers, and strategic deterrents. For our armed forces, I am not a specialist in this topic, but I believe that these are the real mission critical assets. And for the nation, they represent our sovereignty in motion, silent, persistent, and intelligent. At IIT Kharagpur, we do not treat underwater systems as isolated engineering artifacts. Much before taking over as a director, I have got an overall familiarity because this program is led by my departmental colleague Professor C.S. Kumar, and I have seen some of the facilities that he has been developing over the years, even before this, much before this Center of Excellence took off. So mechanical engineering contributes significantly, but that's not all. We have many aspects of the design: propulsion design, structural robustness, and fluid structure interaction expertise. And Ocean Engineering and Naval Architecture department brings deep insights into such hydrodynamics, maneuverability, stability and marine operations. And of course, all of you are aware that other than IIT Madras, we are perhaps the only major national institute to host such a full-fledged department, and in fact we are much more inclusive than the scope of the corresponding department at IIT Madras. At the same time, electrical engineering research, which gets into all these, advances the sensing architectures and power systems. Computer science and AI drives autonomy and adaptive control. Material science addresses corrosion resistance and pressure tolerant materials introduction. So this is complete interdisciplinary and convergence collaboration, not in a superficial sense, it is a deep technological fusion. And this is the kind of convergence that, if nurtured, can produce not incremental improvements but transformative capabilities. So, as I mentioned, at least according to my own impression and because of my interest in fluid structure interactions and soft matter, the successful completion of the biomimetic fish project led by Professor C.S. Kumar himself, instead of fighting hydrodynamics, this enabled learning from the nature's perfection. Fish move with near zero acoustic signatures. They maneuver with elegance and precision. This is nature gifted. By studying such biological systems closely, we can indeed translate natural intelligence into engineering architecture. And that should be one of the major building blocks of the technology advancements in these areas. How much biomimicry we can bring in to the cutting edge technology. By studying such biological systems, the outcome can be a surveillance grade bio-inspired underwater platform characterized by low noise propulsion, enhanced stealth and exceptional agility. This is not any kind of what I would say simple academic exercise. It can actually lead to bio-inspired strategic engineering for defense. Now let me talk a bit about the general aspirations of the center as we move ahead in the next phase of the program, and I think today is the day 0. So of course, in this particular topic, I am spending a bit of time on the topic because although we are talking about the COE overall, the conference is on a focus topic. So we aim to move beyond a single platform towards swarm coordination, embedded AI for adaptive navigation, extended endurance through improved power systems, and mission specific payload integration. And this DRDO can really guide us of how to go about it. So in particular this domain, the phase 2 research is not about refining a prototype, so that will be incremental, but about redefining the underwater autonomy. It is about building systems that can sense, decide, adapt and collaborate in dynamic underwater environment without constant human intervention. There will be human intervention, but it is not like a constant intervention that would be required. So looking ahead, the evolution of unmanned underwater systems will be shaped by 5 powerful revolutions according to me. The first is the energy revolution. Advanced batteries and hybrid power systems that can enable long duration missions. The second is the autonomy revolution, AI driven adaptive navigation capable of operating in uncertain GPS denied environments. The third is swarm intelligence, distributed networks of underwater agents cooperating to achieve complex objectives. The fourth one is secure communication, hybrid acoustic and optical communication strategies for resilient data exchange. And the fifth one is bio-inspired engineering, design philosophies that minimize detectability while maximizing maneuverability and endurance. Why IIT Kharagpur should lead this? Because we have the true intellectual breadth, the nature of the departments, starting from bio, nano, materials, electronics, AI, the core engineering, electrical and mechanical and so on. So we possess the intellectual capability and technological ecosystem to contribute to this meaningfully and lead in each of these areas, isolated and combined. Now coming a bit more into the general aspirations of the center. If I reflect on the previous deliberation, we are absolutely in sync with the three major points that have been raised. One is, number one is practically based PhD program. All of us have recently looked into that Nature article, which deliberated how some universities of China are working on this. But not just some universities of China, worldwide at many places in different forms, such PhD programs have been existing, but not holistically. You will all be very happy to know that on our dean's level, we have almost completed a draft of this program and it will be put to the upcoming Senate for approval, and this we are trying to build up a national level thing, and I will communicate to the Honorable Education Minister, where the comprehensive details that we have all worked out together, it is almost like a research publication, that how such program should be launched. Because on one side it is aspirational, on another side if we do not do it well, there is a chance of significant dilution in the PhD program. Someone will bring a dabba like that, AI conference moving thing and claim that it is a PhD out of innovation. That we have to stop. So we have to bring in new things without sacrificing the rigor and in fact tightening the rigor more. And we have built up such a program. I believe that when launched, it will be a nationally new thing. My request to the DRDO team and Dr. Das is to become the first champion, first you can call it industrial champion or R&D champion. I would not like to call DRDO as an industry. It is not fair because DRDO is much broader than an industry. It's a national pride. So if DRDO becomes our first partner, where we arrange for the scholarships for the students, but use support for the physical facilities needed to build up the system and the prototype and the product. So I think that whenever I will be communicating this to the Ministry of Education, I will be doing it soon, not maybe far from the next Senate meeting. And next Senate meeting we are planning within the next 3 weeks. So we should by that time be ready with a support letter from this DRDO center that if we support this program academically, the prototype facilitation and mentoring for making them really practical for the national cause will be mentored by this DRDO center. This is number one. So this is done. Number two, innovation and entrepreneurship space, the startup thing. We have already completed the new startup policy of the institute, where we are encouraging the faculty members and students to be active parts of the startups. And we have got some kinds of programs where we can embed that even into the curriculum with certain facilities to the students like deferred placement, making this as a part of their thesis, say undergraduate thesis, master's thesis. So whatever they are going to do as a part of this startup, if that has significant intellectual component, that can replace the traditional this manuscript style of working on the thesis at all levels, undergraduate, masters and PhD. PhD one will take a bit of time to establish as a standard, but undergraduate and masters straight away from these startup things. So for this also, I would request Dr. Das to build up a system and a framework and some kind of manifesto, so that DRDO becomes an integral part of this startup innovation ecosystem, where faculty and students are direct stakeholders of such startup. Defense and space are those deep tech areas where if we do not get into these kind of startups, we cannot really contribute to a scalable national development. And let this DRDO Center of Excellence be the prime driver for this. Institute will provide all support, but the center has to be proactive for this. Institute will not be imposing or instructive to the center. Center should work out the details in consultation with all the experts who are here today, and some experts possibly could not come, but you can do all this, and we will definitely facilitate through this by possibly with the engagement of DFTM DRDO. And if we combine all these, we want our center to be as vibrant as some of that in MIT or other places where such deep tech activities flourish in line with the best of the global practice. So I would request Dr. Das to look into those models and include all these with more practically oriented, deployment oriented research, engaging startups, engaging other industry, and with high quality visiting scientists and researchers. Today morning when I was conversing in the online interaction with the Honorable Chairman of DRDO, I emphasized that we should have a center where we would not be segregating who is from DRDO and who is from IIT Kharagpur. That is the first thing. So let us propose in this way that be from DRDO, be from IIT Kharagpur, or be from a third organization which has that high level of knowledge and technology and all. We should accommodate them in any form of scientific position or faculty position, depending on their areas, etc. And we are flexible to give appropriate nomenclatures to honor such persons and also provide all the incentives, including lab access, access to students and teaching courses that our usual faculty members will have. So our faculty are ready, and I am so happy to see not just faculty present here, but they are representing different departments, and that shows the kind of interdisciplinary flair that we are having. Our students are deeply motivated. Just today morning, one of our second year BTech students, he was desperate to meet with his ideas with the Honorable Chairman of DRDO. Last 2-3 days he has been writing emails to me and I did not reply specifically because I thought that if he had come physically, at least for 5 minutes or so, I could have called the student. But now that he could not physically come, he just now came to my office just before this program, and I entertained what he was trying to say. And these are very young, dynamic, enthusiastic students. We have to imagine they will not have that kind of knowledge that very senior and established scientists will be having, but they have lot of promising ideas. So we should encourage such people. Our labs are reasonably well equipped, but we must have advanced prototyping. Otherwise, whatever the little bit of thing in the lab we are doing, they will only churn mediocre papers. We really want to build up systems, and for that we request the kind support of DRDO for the creating the facilities for prototyping. And in that way we can amplify the impact, and this center of excellence can be a strategic decision making and acceleration facilitator. Speed in research funding, quick decisions, innovation compounds, and with all these together, I think that this will definitely gain momentum, capability, and grow exponentially, and this center will be the true national hub where it will be a delight for all scientists, all technologists who are working on the relevant field to come and work together. Beyond the unmanned underwater vehicles activities, IIT Kharagpur stands ready to take leadership in many broader aspects of technology through this center. We write individual projects for DRDO and all, but I think that is not for an institute like IIT Kharagpur in its platinum jubilee year. So we can definitely bring into focus many such areas and build up programs around this center. No more projects, but programs. For example, cyber security and hardware security for strategic infrastructure, advanced battery technologies for tactical and autonomous systems, healthcare technologies tailored for defense personnel operating under extreme conditions. IIT Kharagpur is the first to launch the School of Medical Science and Technology 25 years back, at a time when in the country technology and medical research working together was not a very common thing. It is not this era where everyone talks about medtech. So obviously we hold certain advantages, and I wish, and many of these advantages are due to the development of wearable point of care solutions, which will be very effective for maybe soldiers or others who work at very challenging conditions, and we can definitely facilitate such things. These are the things which we should start, otherwise someone else will do and maybe we will follow a Chinese dog. This is not good. And specialized AI and machine learning for defense based applications, platform technology. We must move from isolated project based engagements. So when I see the activity of such a center, we count by number of projects, some 10 projects, 20 projects, faculty members submit, it is reviewed. That ANRF does regularly. Why do we need a DRDO center for this? This is my fundamental question. We should not have a center where the objective is just to fund 10 projects with this meager amount. Institute of such a gamut and of such an aspiration should have this center linked with something which is matching with the aspirations. So we must move from isolated project based engagements to mission driven partnerships, and that mission driven partnership, be it in technology area, be in PhD academic program, or be industry academia cooperation with startup and entrepreneurial ecosystem, and all combined together. From incremental upgrades to disruptive capability leads. And indeed, the DIA-CoE at IIT Kharagpur has the potential to evolve into a national hub for such systems. What we must build is not merely some kind of hardware for research. We must build the capability sovereignty so that we can do it completely by ourselves. Systems that are designed, developed, validated and matured within the nation and aligned with the nation's strategic priorities. I am extremely confident about the leadership of this unit. Dr. Deepak Das is very, very capable and we all must support him to make this center exponentially grow like this. To some of the young researchers and students present here, of course, you have not come for a generic deliberation on the CoE, but more specifically on the particular thematic area. The oceans are not silent. They speak through turbulence, pressure gradients, elegance of biological systems perfected over millions of years, and that is how they survive so nicely in the deep ocean. Your task is not merely to design underwater vehicles. Your task is to engineer intelligence that survives uncertainty and create systems that adapt like living organisms, and to develop technologies that protect those who protect us nationally. This is not just research, it is a national responsibility. In the coming decades, the global power will not be measured only by what flies in the sky or orbits in the space. It will also be measured by what moves unseen beneath the water, persistently, intelligently and strategically. So in terms of this focused conference, let IIT Kharagpur and DRDO together ensure that in the story of underwater technological dominance, India does not follow, India leads. Thank you. Namaskar. Jai Hind.
Thank you, sir, for your very inspiring address. Now we have a very short tea break outside this hall, and after the tea break, 15 minutes, and we'll come back to hall here only. So all of you, please have your tea outside this hall, please.
Test. Test.
हेलो 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 ठीक है ना ओके
So we now move to the keynote lectures. I request all of you, please take your seats. It is my honor to invite Dr. Abraham Varghese, Director NSTL, to deliver the keynote address. Should I start? So we now move to the keynote lectures. It is my honor to invite Dr. Abraham Varghese, Director NSTL, to deliver the keynote address. Dr. Abraham Varghese, Scientist G, assumed charge as a Director, Naval Science and Technological Laboratory in July 2023. He is an alumnus of the University of Kerala and IIT Delhi. Dr. Varghese holds a doctorate in computer science and engineering from Andhra University and was awarded the gold medal for the best PhD in the engineering stream. He has over 3 decades of experience in the design and development of naval system and lead the indigenous development of underwater weapons at the laboratory. He is the chairman of IEEE Visakhapatnam Base Sections and a fellow of several professional societies. Now I invite Dr. Abraham Varghese to share your valuable thought with us. Sir, please.
Director General Technology Management, Sri L.C. Mangal, Dr. Ranjana, Dr. Deepak Das, Professor Kumar, Prince Joseph, Sri Bharadwaj, and friends from DRDO, and also friends Dr. Deepak Das, and friends from IIT Kharagpur. As you all know, underwater robotics involves the design, development and deployment of devices for operation in subaquatic environments often replacing humans in hazardous deep sea tasks. These systems are essentially for defense and also for civilian purpose like offshore energy, scientific research, defense and environment monitoring. In the past century, developments in underwater robotics have allowed technology to emerge from a purely military role to dual use, one that finds widespread, especially in offshore, oil and gas industries and scientific industries. At NSTL, we work on underwater vehicles, and the primary task of NSTL is basically to develop underwater weapons, then hydrodynamic research, naval stealth, then underwater mines, and associated technologies. If you see the technological challenges which has been elaborated in my previous in the previous speeches here also, you can see the navigation is one of the very critical area in underwater scenario, because the non-availability of GPS and not penetration of RF signals in the underwater scenario makes the navigation very difficult proposition in underwater. Second thing is the high latency in the communication. In the terrestrial domain, you get the data passed on very fast, but in underwater, the latency is very high. So when you develop a protocol stack for underwater, you get so many drop packets, and your error rate is very high. As I have seen, although acoustic modems claim 3 kilometers, more than 3 kilometers with high baud rates, but on actual ground, I have seen you don't get more than 4800 baud, and that too on a very good day. Very good day means the underwater communication largely depends on the bathymetric profile. You need to have a good temperature profile, then only the communication, the acoustic waves can travel well. Otherwise, the ray is going to bend. So on a good day, when the bathymetry is very good, the acoustic modems may behave well. But if you have got a negative temperature profile, then your ranges are going to come down from 2 kilometers drastically to 500 meters or so. So this is one of the very important criteria when you consider the communications in underwater scenario. And another major constraint is the hydrostatic pressure. If you have to develop a system for underwater, the hydrostatic pressure plays a major role. So if you have to design a system for a underwater scenario, then your thickness of your structure will vary as per the depth where it has to be deployed. If you consider a 500 meter where you have to deploy, your structure has to be almost 6 to 7 mm thick, which contributes to the weight of the system to a great extent. So that is another criteria. Another thing is the corrosive environment, which has been mentioned earlier, and of course the seamanship. To deploy any system in underwater scenario or on the sea, you need the seamanship. The sea state play a major role. On that, the wind and this one play a major role. So the seamanship also play a major role. If you if you consider the this is basically, I would like to go in this way. Basically, I will give an introduction of the global scenario, then the present situation, and the way ahead. I will just touch upon the way ahead. If you see that various technologies which are involved for the underwater vehicles, the first thing is of course the energy source. If you see an underwater vehicle, the most of the space will be occupied by the energy source. The battery will be occupying. If you consider a electrical underwater vehicle, of course there are other underwater vehicles which are based on a thermal engine. But if you consider electrical vehicle, the most of the space will be occupied by the battery. The battery can be, earlier we used to have the silver zinc technology. Now we are given to lithium-ion technology. And also there are other underwater vehicles which works on seawater as the electrolyte. If you consider magnesium silver chloride chemistry, it works on a seawater electrolyte concept, so that you will be able to reduce the weight of your energy source, and you can take in seawater and make the energy available. And next one is the prime mover, the motor, the electrical motor which is operating in the underwater. So that is another technology where now BLDC motors are coming up. and also PMS and permanent matter synchronous motors are coming up. NSTL has expertise has developed both in the case of lithium-ion batteries and permanent matter synchronous motors. NSTL has got a very vast expertise. And another thing I have mentioned, the communication, the acoustic communication is another area. Mechanical structure just now mentioned, as the depth goes, you need to have thicker mechanical shells, which all your stress, strain, everything you need to get consider. Another thing is the sealing technology. You have got moving parts in an underwater vehicles, so the water ingress has to be prevented. So you need to have dynamic seals to be positioned wherever you have got a rubbing surface. So that is another area where when you consider an underwater vehicle which will move over 10 knots, 10 to 15 knots, then all these design constraints come into play. And of course the sonars. If you have to detect another object in the underwater, you have to deploy the sonars. The sonars also various types. You have to have a obstacle avoidance sonars, because when the vehicle moves, you need to avoid an obstacle. Then you need to have a obstacle avoidance sonar. Then if you have to scan some of the things underneath, then you need to have a bottom scan sonar, side scan sonar. So the plethora of sonars come into play in the underwater based on the size and shape of the vehicle. Another thing is the stealth. The underwater vehicle need to be stealthier, because once you launch, if the radiated noise is quite high, the underwater vehicle can be detected at a quite distance. So in case of a military scenario, that becomes a problem. So the vehicle as such has to produce a lesser noise. So the stealthy technologies are to be employed for the underwater. As far as NSTL is concerned, NSTL has got exhaustive facilities for testing these underwater vehicles. We have got the high-speed towing tank, which is unique, I think, this part of the Asia, which is available, and also a cavitation tunnel, which can test all your propellers. Then the sea keeping and maneuvering basin, where you can test the maneuverability of the vehicle. So these facilities are quite unique, and maybe in the South Asia, which is available of this magnitude, is available only in NSTL. Right now, the government mandate is that any warship which is being made in India has to be tested, the model has to be tested in NSTL, because earlier it used to be tested abroad, but now the mandate. And we are also having a new facility called large cavitation tunnel, which is coming up. Dr. Bharadwaj, everything were involved in that one. So this is another facility which is coming up. Next. So I was touching upon the various technologies. So if you see a bookish definition in the maritime domain, unmanned surface vehicles and unmanned aerial vehicles have come into sharp focus in the recent times, because you have seen the Ukraine war, where the applicability of these asymmetric warfare has come to the forefront, where the low-cost solutions are able to do a damage compared to the other costlier solutions. So the underwater vehicles have suddenly come into prominence, because Ukraine has effectively utilized these assets to counter the opposition. For anti-submarine warfare operation, lot of navies cannot afford to have a submarine for that one, but certainly they can afford to have a fleet of unmanned vehicles which can detect the opposition, and also it can launch some anti-submarine operations. And also compared to a large manned asset, these platforms are quiet and radiating less noise, and also the cost is less and the signature is less. All those advantages we are having. And in the underwater vehicles, the key technologies, other than what I listed earlier, the perception technologies is a combination of sonar and other sensors. Long-range obstacle detection is another critical area. And other technologies which are coming other than the acoustic communications are the blue-green laser, although it can offer a very short range, that can be used for a smaller, shorter range. So I just listed down some of the internet photos of the various underwater vehicles which are available across the worldwide. There can be subsurface vehicles, there can be the surface vehicles which can be there on the surface, it can be gliders, and the shapes can be launched from a submarine, it can be deployed from another ship. So like that, it can be various things are already available, if you can see. And there are also some of the places they are also networked, where a common network will be able to launch these things, and they will have a large number of sensors on board. So coming to the various issues which are relevant in the underwater vehicles are, one is the interoperability. So synergized capabilities of manned and unmanned teaming, you know, so that we should be able to connect because of the using the open architectures, you should be able to connect. Then autonomy. So autonomous underwater vehicles, what level of autonomy, you have got different levels of autonomy which has to be employed, sensing, and whether a man has to be there in loop to make a final decision. So all those are the other scenarios which are involved. So other thing is the communication security, because when you are having a communication over the medium, so how the communication can be cryptic, all those things we need to, and of course the human machine collaboration. When you have to give a command from a central station, you need to, or when you have to operate at a certain depth, you need to give the commands. So that all those are the other issues which are involved in the unmanned vehicles. So coming to the unmanned underwater vehicles, they are submersible vehicles that contain independent propulsion system. As I elaborated earlier, they have got autonomous propulsion system, mostly electrical batteries, and now whatever the other energy harvesting techniques are coming, where you have got the solar energy up to certain depth, and also thermal engines are another systems which are coming out for the energy, this one. Then the payload sensors, there can be a variety of payload sensors like sonars, and when it comes to surface, if you have to detect something, you can have a short range radar which can detect some of the objects. And there are various classifications of this one. First, of course, the autonomous underwater vehicles. Then it can be remotely operated vehicles using a tether. You can operate. It can be a electrical wire, or it can be optical wire, where when you can accommodate longer lengths. And the gliders, of course, utilizing the surface energy, you can have a glider. So these are the basic classification of autonomous underwater vehicles. And coming to the various AUVs, as I mentioned, AUVs are autonomous missions which have got an onboard computer. So based on the sensor data and based on the other sensor information, it could be able to execute a mission. And it can also will have communication structure so that it can report back to the central command center, or in the case of any civilian applications, if you want to recover something, or if you want to inspect a underwater site. So all those things can be done autonomously, and you can see the right side, the imaging, how we can do. Anyway, my colleague will be explaining this afternoon, where how it is able to detect using acoustics, how it is able to detect an object, and optically how it can be done. So then, of course, after that you can, as the energy is always limited, you need to recover it, then you need to recharge it, and also the data retrieval and all other mechanisms are to be there. So remotely operated vehicles are basically, it is connected to the launch system or launch computer using a tether. The tether can be a normal electric wire, but you will have the heavy attenuation will be there, so you will be limited by the length of the wire. So, but if an optical fiber is there, then repeatless communication can be there to a great longer length, so that you will be able to feed the information, and then you will be able to get back the data, what is it inspecting, or what is the data, so that the man on board can make a decision. These are the second class of remotely operated vehicles. And third thing is the underwater gliders. I think NSTL is working on this one. The gliders are low-speed vehicles that utilize the weight and buoyancy vectors, so that without much energy, you can see the way it can go on the surface or just below the surface. So AUV also, there are various weight classes are there. The extra large AUVs, you can see now recently in the literature you could see. Then large AUVs were 10 tons, then heavyweight AUVs, the lightweight, man portable, and micro. These are the various class of underwater vehicles which are available. If you consider now, if in recent whatever the wars which have happened also, lightweight and man portable AUVs have been used quite a large extent to have asymmetric warfare, because they are low cost and you are able to deploy them very easily. And heavyweight AUVs are generally sparingly used, and also there are other AUVs where extra large AUVs or very long endurance AUVs which can be launched to have a surveillance, and then you can feed the data back. And there are other things, are hybrid autonomous vehicles are also coming up. So we can see some of the internal literature where which are the lightweight and man-portable AUVs which are extensively used. The bluefin, the Rumors, the operations also you can see wherever the operations, and the bluefin was extensively used in the MH370 search, which was used for quite a long time for searching the vast area. So these are the lightweight and man-portable AUVs which are extensively used. So coming to DRDO's man-portable AUV, NSCL has developed man-portable AUVs which are all tested and is being deployed for various applications, although it is likely to go the user trial so that it will be inducted to this one. So these are basically some of AUVs which have got various, you can see various payloads are possible on board. You have got a surface communication, you have got acoustic communication, and then you have got side scan sonars. So these have been deployed. You could see in the Twitter, maybe Twitter if you see around 5-6 months back, Suresh, 5-6 months back. So we have deployed this one in an area, and the multiple AUVs have been deployed where it could detect the underwater targets, and it has been reported back and to the autonomous surface vehicles. So this has been in-house development, and most of the payloads also have been developed in-house, including the your propeller, your propulsion system, and battery modules. NSCL has got a lithium-ion center is their pilot plant where our technology of lithium-ion is there, which are going to be deployed in the various underwater vehicles. These are the SWAM AUVs. You can see the 4 AUVs which are swimming out to do a collaborative mission. You can see there also in the top. In the Twitter, it will be available in the Twitter. You can see that video also will be available, how it is deployed. And based on the sonar signature and a coordinated effort, it will be able to detect back and report back this one. And also it has got an AI technique. Anyway, my colleagues will be talking about in the afternoon. How it, using an AI technique, how it is able to detect an image and report it back to this one, and based on that one, we can take the action. So in this case, one is the surveillance AUV, and another one is a neutralizer one. If you want to neutralize after if something, then you can deploy a neutralizer AUV. So this in a swarm mode it will work, and the intercommunication will be there, and you will have the, what is the scanning pattern you call? Lawn mover scanning pattern will be there, so that you can cover a very vast area, will be able to cover, so that in a shorter time you can carry with the multiple AUVs in a very large area. So this has been already tested, and it is in the advanced stage of induction. The large displacement, that was the man-portable, that you can just carry, somebody can carry and will be able to deploy, and once you deploy, and it have a come-home function will be there, so it will be able to come to the launch points. So those are the man-portable, and there are large displacement AUVs are also available. You can see various countries have got, these are all from the internet. Blue Whale, then Rubin has got some AUVs and so on. These are all the large displacement AUVs. So their endurance is of the order of 15 to 13 days. Once you deploy, this fellow can go up to the energy source up to 15 to 30 days, and it will be able to do the surveillance and mine countermeasures, and it will be able to report back using a satellite. It will be able to get back. This is the DRDO's high endurance AUV which has been developed. This is a 15 days endurance AUV. So you can see this one AUV which has been deployed. So it has got an endurance for 15 days. Once you deploy it, it can go for the mission for 15 days. It has got so many sensors are there for undertaking multiple missions as per the user requirements. You can see what are the sensors on the side, you can see, and also on the top, the satellite communication and also the UHF communication, all those things are there. The entire, you can also see the application, the submarine detection, mine detection, surface ISR, oceanography, all those operations are possible based on the payload sensors which are there on board. So the entire system has been developed in-house. There are 8 labs are involved in this one, because the main hydrodynamics and the propulsion, battery, everything has been in NSTL, and other labs are involved in the development of the sonars, especially large number of sonars are involved in this one, and other you have got the communication systems. Actually, Mangal sir only was there initially in this project where he was only guiding for all the communication system. Then for the other things like you have got the here also almost the 30-40% of the entire volume will be the lithium ion battery will be there. Then you can see the propeller, you can see the motor, there will be a motor, and so all these technologies are there. So this has been extensively tested. You can see testing in a site where it has been done. So this has got a to a greater depths, and once it launched, it can run for almost more than 15 days. It can run, and it can again come home, and it can report back the whatever the detections which has been done. And it will be also got AI techniques whereby you will be able to using image processing, you will be able to detect mine-like objects or sunken objects. So these are also undergone extensive trials. So this is a very heavy vehicle. This is a 10-meter long vehicle with the weight of almost 8 tons. So this is a very long vehicle. Unlike the other one, which is earlier which I shown, it's a man-portable. Somebody can deploy it and carry it and deploy it. Okay, this yeah. So typical deploy scenarios, you can see if you want to choke points of the wherever it is there, like Malacca Strait or somewhere you have to deploy. So you can these once you deployed, this will be able to go up to that place, do the survey, and then it can report back. And if some sunken objects are there, that also it can be detect. And there are various sonars, as I have mentioned, are there on. But all these sonars are not bought out. It's all are indigenously developed sonars. So all these sonars, various types of sonars have been with various labs. It have been indigenously developed. Okay, these are the mine countermeasure scenarios where it can you can do a scanning, and it can so you can see the bottom sonar is the side scan sonar. It will be able to detect this one using an image processing, acoustic image processing. It will be able to detect the objects, and it will be able to. These are extra large AUVs which I taken from the internet, where they can launch weapons also. So they'll be able to launch weapons. This is the Boeing Orca, which is available for quite some time. So they will be able to launch some of the weapons. And it is not an electric one. It is a diesel one, electric. It is a hybrid one. So this also has got quite long range, almost 45 days, and it can stay in 6 months in the underwater. Once you launch, it can. So that is what the literature available on board internet says. And another thing is, of course, you know, the Mandare AUV, which US has done based on this one, and Professor Kumar and team has now done the biomimetic AUV, so which has been recently has been demonstrated, so which now can grow to the next stage where it can do some surveillance, because the stealth is one of the important feature of that one, so it will be able to, it can do the surveillance and report back. So that is also one great development which was done by IIT Kharagpur along with the other institutes. So this one, actually the Mandare was been developed by, it is being used by the US Navy, you can see. So it has got a variety of missions it can do, independent of the motherships. So it can also, based on the mission, it can be, you can also make it, the mission specific also you can make. So significant, these are the significant AUVs which are available the worldwide. Recently the Ghost Shark you have seen the Australian Navy has displayed, and there are other things which are torpedo-like AUVs are available. So we are also, this is an extra large, not the high endurance class, it's the extra large class. Wave glider, of course, by using the surface float and a sub at depth, we will be with a buoyancy engine you will be able to use. I think Dr. Bharadwaj and team has worked extensively on this one wave glider, and these are some of the imported wave glider. I think the Navy is also having this one. So other things are hybrid AUVs are there, capable of being used either in AUV mode or in ROV mode, with a tether or not with a tether, with a greater flexibility in carrying out complex mission, and also the mine neutralization is one of the other application whether it can do. So you can see that video there. It is being launched from a platform, and then it can it will do the scan. This is a video which I taken from the internet. So it is coming back to the and docking to the original system. I think now they are working on the all the docking systems, everything. So it is the technology is how do we will come and position at the same place. So acoustic and optical docking systems are available. So this you can see, and AUV launching as ASV is launching a torpedo. This is LBIT system, LBIT Israel system. So it is able to launch it from a surface. ASV is launching a torpedo, and the bottom one you can see it's a drone carrying a AUV and deploying it at the appropriate place. So these are some of the systems which are available elsewhere where internet literature is available. So the way ahead can be the greater levels of autonomy. As you know, the various levels of autonomy are there. Your guidance autonomy, the control autonomy, then your decision making autonomy. So various levels of autonomy can be there. If you want to do a strike, this one, whether man has to be looped, so all those discussions are there. Of course, the networking is the one of the bigger challenges. The underwater communication technology is one of the very, very difficult technology. So as I was mentioning earlier, it all depends on the day's weather and day's underwater profile. Okay, human machine teaming, then higher endurance and range. Once you deploy, how many days it can go, how much range it can go. If you launch from here, whether it can go to the Malacca Strait. So that is the other, you need to have energy packed density, quite what is it called, dense energy pack is to be available, and also power also is another, this one, and also the power consumption by the electronics or the other propulsion system, and then the higher range of the sensors. If your sensor is able to detect at a higher range, that is another challenge which you are having. These are some of the challenges which we are having. Propulsion, batteries, everything already, I think country has come to a stage where NSTL themselves are having that technology for all the lithium-ion batteries now, because technology is have been transferred to various industries. So we have got a pilot plant where we have made this one, and also the propulsion, also BLDC, BLDC motors, all those things are this one. But other like sensors where you can detect for a longer, this one, where you can have more research in that area, when you be able to detect a target at a longer area, or detect a bottom profile, a bottom this one from a greater depth. So, and lightweight materials, because if you have to go to higher depth, the materials have to be lighter materials. So these are the other challenges which are there. Next. Yeah, automated system. So this also I was telling, so how much autonomy has to be there, AIML. So AML really and can take a decision. Okay, something is detected, and the machine language itself, machine learning itself, based on that one, you can take a decision without human. All those things are some of the discussions. You know, the international conventions are there on that one. So all those discussions are in going on. So technologies like deep neural network, neuromorphic computing, AIML, all these are the technologies which have to come up for the AUVs, in addition to the sensors which have this one. This navigation is another technology. See, now GPS is not available, INS you can use, and the magnetic anomaly you can use. See, any place, if you know the magnetic anomaly, you will be able to find out the place. If you measure the magnetic anomaly there, without GPS you are able to find the place. So these are some of the techniques by which the navigation can be done to a greater extent. So you need to have very accurate sensors which have to measure those magnetic anomaly and other data. So there will be, you'll be able to, these are the areas where research have to go, because making sensors, now most of these magnetic anomaly sensors are getting imported. So NPOL is also doing some work, so other labs are doing. So these are some of the technologies where we need to develop so that more and more effectively these underwater vehicles can be. Okay, these are some of the long term. This I told already, the communication systems. What are the communication systems? The various problems with the low latency, higher and the error rate, very high error rate are there, and acoustic communication is limited to very, very less, and very low baud rate only is possible. So these are some of the challenges in there. And human, the machine teaming, the combat management system, how it should address this one. If you have to launch a weapon, or the decision has to be there. These are the other issues which are to be dealt. More endurance I have already covered. So compact sonars and mission payloads, that is one greater area which is there, because you can, wherever you can fit a compact sensor, then it is going to be better communication, sensor fusion, cyber resilience, swarming. Although swarming and cooperative guidance can be done, all those things if you do, then you will be able to have a swarms in a better way. And autonomous modeling and simulation advancements, I think we are using Gazebo, everything we are using now. Yeah, Gazebo we are using. So there can be other platforms which can do these things in a better way. Thank you and Jai Hind. Actually, the autonomous underwater vehicle is a very, very important area which the technologies which is leading to do can be made, because most of the things, although AUVs are being made, most of the sensors, everything getting imported, and especially when we have done the HEAV, we have tried to make all the technologies in-house. We are not buying a sonar from NPL has made some of the sonars. As I told, 8 labs have together made this system. So that is the future of this area. Thank you once again. Yeah.
Thank you, sir, for your informative and engagement sessions. Informative and engagement sessions. We now begin with series of invited lectures. It is my privilege to introduce our first invited speaker, Dr. C.S. Kumar. Dr. C.S. Kumar is a professor in the Department of Mechanical Engineering at the Indian Institute of Technology, Kharagpur. He obtained his BTech and PhD from IIT Kharagpur and has also served as a postdoctoral fellow at IIST Tsukuba, Japan. His research interests include control and autonomous underwater vehicle, fixture-based micro grippers, micro and nano robotics, humanoid robots, and metal additive manufacturing. He also works in areas related to computer networks and advanced engineering system. He is a member of IEEE, ASME, AU VISI, and served in several national advisory roles. At IIT Kharagpur, he is a head of the Rajendra Mishra School of Engineering. Sorry. So I request you, sir, kindly deliver your lectures.
Thank you for that introduction. I'll try to play from here. So it's not a very pleasant thing to be between you and lunch now. So I'll try to be try to cover whatever I can in this. I'll try to be brief as well as cover whatever maximum I can. Some of you, many of the things have been told in earlier by this. For some reason, it's taking a while to open up. It's there, 86% it says, fine. So, what's the time? When should I end it? If you tell accordingly, I'll time it. I know we should have been going for lunch now. Huh? It's 1:20. No, what time should we? When I 1:45. Okay. Yeah. Just yes. So I'll try to keep within that 1:45 time. The purpose of this talk here is to give you an idea like what an academic institute like ours can do, and in fact other academic institutions can also take up activities to deliver some such system oriented projects which are like platforms which can do many things and can be put to use for very other applications in the one aspect of it, and the other aspect of it is it allows to build a team or a knowledge base and that kind of capability building, what we say, over the years in a particular domain, And as mentioned by all the eminent speakers before, including our director, that it takes several years of efforts, and it's not that it's not replicable, it's a niche area, but then you can still replicate it in different ways here. So this, I will share some experiences on this here. So what you see here is 3 autonomous underwater vehicles which are available in our lab, and all of them are operational with the different kind of levels of capabilities. And at least to the best of my knowledge, I don't know if any other institute or university in this country has this 3 such operational vehicles which can be put to use in anytime, on demand, almost on demand we are ready. This is something which started long ago, but we were not in that position till a few years ago, and thanks to DRDO that we could do something by which these are all available. And very recently Dr. Abraham had left for his next meeting. It was thanks to them, they hosted us, and we could take these 3 vehicles there and actually test something in their facility. So as the topic goes, for the futuristic underwater system, we should get prepared. So I will share a few things which will take it to, we should get ready for that kind of scenarios. Now, I won't spend much time on this, just as an introduction prepared. Why underwater, and what is a very big, strategically, as everybody told this morning, is so significant for us, is because it is something which very few of us, we take it for granted. The planet on which we are living is having our Earth is 97% of the Earth is water. You won't believe it. Okay, it's what this, the statistics will reveal and all. And the surface is about 70% of it is there, is oceans. And we are living on only that small fraction, and a lot of things are hidden in this which very little is known from a science perspective, though the oldest of life form also evolved in the seas, on this earth, the living, but it has its own mysteries which are there, and not everyone is familiar with this, and it is therefore, as everyone else mentioned this morning, several have told, it's more challenging to work with in these environments by engineers. For engineers, it's a challenge. It's something which we don't get to see often, unlike something which flies, something which moves on roads, something which goes into space. All of these are well visible, everything are monitorable, but not so in the water or underwater domain. And the other aspect of it is, therefore, you can actually have a very secretive thing inside that. It is one of, though it's such a large thing, the world over, strategically, most of the countries, the advanced countries, they hide most of their secrets in the underwater domain. Okay, that is a military concept. If you talk to anyone there, they will all tell about it. It is there because it's not visible to anyone, and that's your kind of hidden closet wherein you can keep most of it. The submarine can go in places no one will know where it is, and it will suddenly do something which you're not prepared for. Okay, and it is using some of the most sophisticated technologies also in this process. So working on that is a very strategic area, very niche area in which some or the other have to be trained. And when you get these projects, and when we take this, when it was first discussed about more than almost 30 years ago, it was something which people should feel the necessity of it and that we have to take these up. So we are happy to have worked on that, and I will share this. One of the things I mentioned here is the water technologies is something which we also nurture by when you work on surface water technologies, where ships and all are there, where ship science has been there for a while. It is visible, it is monitorable, it is all there, but that is, you have several expertise available on it. Again, when you go into subsea, it becomes a challenge. And then, as rightly everyone said this morning, including the last talk, robotization of this means all autonomy hidden, nothing known to anyone there. It's most stealth operations are possible there, is always the strongest of this one is available there. It's in fact even more so than that in the space, because even in space you can monitor what's going on. So, at our institute we had two levels of activities first. We did not get into the military technologies first. We were first doing it for economic purposes, and the so-called blue economy is still live and valid, which this basically, as I mentioned in the large numbers, there is also a huge amount of energy resources, minerals and other kind of materials available, including drugs, which are suitable for living, are hidden in the seas, and we don't know much about it. So exploration and identifying that has been the first one, and we were able to get that, do some activity in that through a joint collaborative work, even from CSIR, CMER, team members are here, that we could do some underwater robotics work there, okay, autonomous vehicles for that. And more recently is the biomimetic version, which is the second part of it, which is a fish-inspired locomotion, which facilitated these kind of robotic activities. So these are the two things which I will talk about here to bring to you how these technologies can be nurtured and developed at institutional scale, academics getting involved, and with good partnerships you can meet the challenges with what they are saying. And I'm happy it has been included as one of the topics of DIA-CoE of IIT Kharagpur here. At IIT Kharagpur, many departments are involved. It is not a single this one in it, and ranging from ocean science, mechanical, electrical, electronics, communications, name it, all of them are involved. Materials, and even in the agriculture and food engineering, they have a wing. I think Professor Vishwanath is here. He heads that, the aquaculture group, wherein they also look at how fishes can be cultured and all that. In a broad class of things that we have here, I will talk, today's talk will be broken down into the first version of the vehicles which we had were more propeller driven. We call propellers. Propellers are part of what we call as thrusters. Thrusters generate forces, and the forces can be used to move the vehicles in water. Okay, that is the first type of vehicles that are coming. Okay, then there have been a combination of all the examples that you have seen. Some are thruster driven, and some have fins which can guide the vehicles, and these are called hybrid thruster fin vehicles. And we'll lastly talk about fin controlled vehicles, which are the ones, is the last part, which I will give more examples and perhaps show some exciting videos as well. Okay. So the thruster one is the first one, wherein CSIR, CMER was a partner. They are here also. They also work on this, and this region had got identified as a region which can support the underwater robotic activities. So many of these are there earlier. I will not go through these. These are different kind of it which is there. So here is the first one which was done, which ended way back in 2011. But IIT Kharagpur's part of it ended by 2007, wherein we had a vehicle which could actually swim around using, this is in the swimming pool video, it could swim around with thrusters. Okay. And this is, as I said, as old, it's 20 years, almost 20 years now. The project started in 2003, and the bigger version of it, which was the real one, which had to go to sea, was having a 150 meter depth operation it should go, and it was tested in an NPOL facility in Kulamau near Kochi, and it eventually went to the sea in 2011 only at that time. And the version that we first made was a small test bed version. Test beds allow you to experiment a lot of things without actually doing all the complexities inside it without having to go to very complex environments. And the one which you saw there was having a similar replica of the thing. An entire thing was assembled and made in the country, in our this one, and in the lab, and it had all kind of control systems inside it, integrated control architectures and thruster controls, everything put into it. Everything was in-house on a real-time operating system which could be procured, and the entire architecture of this thing was put in here. At that point of time, there was no parallel work anywhere else, and any other work going on was relying on and help from another country also. So this is completely indigenous work, and that which ended that time we have again revived recently with Divakar, who is my student who has just submitted his thesis and is defending it. He could get this back into operation and do many more level of control operations on it and get it back into operation, because at that time with the limited fund we had, we could do a few things. Now much more detailed characterization could be done in the way we want it, and he could optimize it with much better control capabilities and implement most recent control features into it. So here are some videos which actually show how this goes down a thing, and this video goes how it makes moving inside a tank or towing tank here, and that's this one here. And the entire thing had a tracking and monitoring system with its own with a built-in INS, with our own built-in INS for this. So this is, as I said, is active. It's a picture of it in our the pool which we have. It's inside a small space also it can actually navigate and move around, and these are certain things you can do with this robotic device. It has gone to NPOL, to NSTL as well. We are maintaining this with trying to compare with the signature. There's a lot of sound signature with this and that of the one in the biomimetic one, and that's why we reactivated this also for it. Having said that, now let me come to the most exciting part which DRDO supported, and it there was a lot of deliberations and saying that why we should go into a fish-like thing which mimics a natural system, and does it have a kind of a stealth, giving some kind of surveillance capability that we can get, which the thruster ones do not have that kind of ability. So this was a project which started in 2019 and just concluded this 2020. It was last month of 2019, and we had COVID effects and all, but last December it ended. It was a 3-institute project with IIT Kharagpur, IIT Madras and ISC Bangalore. A multi-institutional project actually makes the team work so much differently, and it makes us reach the target set to us so effectively that it was a pleasure working on this. Okay. So by the topic you can understand what is the goal here. Okay. So these are the ones, you can see a team size of this involved. Teams come, meet, we meet regularly, we still have our weekly meetings although the projects are over, and this is the first version. We have to develop 2 such vehicles. This is the first version and this is the second version here, and it was demonstrated even to the chairman because he took personal interest in this project as well. So these are the 2 vehicles when they were there. The team is exhaustive, as I said, pretty big, which is and several of my colleagues are sitting here, and students are also there which have been. So these things start with very simplistic way, very simple. You could, if you go to the net, you will see lot of toy-like versions which are there in variety of universities. It's not that it is people are not working on it; they are there. Okay, and it all started with the MIT tuna fish, and you can even procure some of these even in the Amazon and play around with this. But that's one part of it. The point here, what is required is what will we require for a large scale version that we had to make, which will serve the purpose of national security, the defense requirements, military requirements perhaps. So all of this had one thing in common. They were locomotion which had to be generated. How do you generate the locomotion capability in this? That it has to have a fish-like locomotive capability. So this one had a biomimetic part of it was to do with a tail which had to be having the fish-like oscillatory capability, and we had our own, these slides are perhaps a little here and there. I'm sorry. I think they have some, it has an interesting mechanism sitting inside it which we designed, and it allows us to do a oscillation that is coming through this, and which can be transmitted to the fluid, and from there it will generate a propulsive force by, not by the regular thruster like thing, it goes by a vortex shedding method. And in air is one thing, but if you do this in water, it has a different phenomena here, and this generates variety of forces. Another thing that has here is there is a flexible element put into it. It is to give a bit of the effect of flexible body and structure that a fish has. Okay, and all kind of this were first started off in the lab first like this. Prior to that, it had to be done in a scale. I mean, that is the version that is there you've seen, but there was no confidence. We had to say whether we can do this on a big scale. So first we wanted to do on a small scale, and in a small scale itself this could be done here, and I believe there are videos here also. Maybe it doesn't matter. And finally, when we made it into the large scale, two versions were made. We called them as P1 and P2. They are almost similar in geometry. They have additional fins which are there to control the movement of the maneuvering movements of this vehicle. And this one is inspired by, I think I missed those slides here, inspired by the shape of a local locally available fish, which is, this region is known for the Bhetki fish. It is also called as the Asian sea bass, and that has a shape which has like this, which has been derived from a real fish. This one, it has been scanned, and the shape of this has been taken from there, and to it these other fins were added, and to give the other control abilities in it. Okay. Now, the next thing to be done was translating that shape into a real product. So you have to somewhere make it as an engineering design. The engineering of it is pretty involved. You have to have a pretty safe and secure system which will ensure that whatever electronics and all that which are conventionally available or advanced versions of it, they still need to be protected from water ingress, and you don't want them to be damaged when this fish goes into deep into water. So you have to have hull forms, and then to the hull you should have fittings which will allow this to move, and all kind of variants had to be done, and this work had come from ISC Bangalore. And this, when we put together, you had to ensure that the fish is floating and doing its activities in a very neutrally buoyant condition, and it had to have foam placed inside an outer shell, and a typical fish-like assembly looks like here. I must admit today, I think for the first time we are revealing these pictures to the public. Okay, This is one thing. So far it has been in the closed confines of it. I think in the public this is coming out for the first time today. Okay. The next version of it had all kind of things to ensure that it had safe protection and yet be floating capability. For that you had to use some kind of foam inside this. The foam that you see here was one of the most complex materials to work with. It is something which we did not foresee in the beginning, but as we do the project such things come out. Okay. And then you implement the mechanisms with all the sonar and other devices into it, and then finally you see a version of it which has built into it, which is an assembled version tested in the tanks there. So I said foam can be a challenge, something which started with this, which tends to give all kind of problems, leaks and water ingress and all that. You finally been able to overcome within a very professional scale with a startup sitting near the campus. So you will be amazed to know how industry can get involved, and such a startup grew up from the campus itself in the ocean engineering department. Okay, so these are some of there are some features of it. I will not go through it in the lack of time. Now, working with tails is not an easy thing. You had to have variety of this. A scientific study had to be done. So ISC Bangalore made several versions of these tails. Some of them did good performance, some did not do that well. And according to that, you had to make variants of this and work out all the characterization across this. And it's been a task. You have to do several tests and trials and before you come into put it to a full use. And these are the two versions which had their own. Now, that apart, those are design things. You also need to know what is the characteristic of this vehicle. The characteristics of these vehicles are obtained from the vehicle did not exist first. You had to depend on mathematical models. The mathematical models were mostly simulation driven, and CFD, as you all know, computational fluid dynamics, is one of the driving platform to study this. Our ocean engineering department looked at the same shape and came up with lots of coefficients that are required to ensure this is there. These studies go into very detail what happens when the vehicle is moving in different directions and how the vortexes are formed and how the pressure gradients take place across it and what will it do to the motion of the vehicle in it. So these kind of exhaustive studies only specialists can understand, and they did this analysis and it revealed things which could be used in our computation. Similarly, that's the body. We also had to do it for the foils which control these surfaces. And having considered all of this, they came up with so many set of coefficients. This is not a small number. There are, I think, around 20 or 23 such coefficients they are considering, which are used in the models. And these have to be realistic coefficients. They are not just simply computed. You have to match them. So they have advanced dynamometry facilities which allows us to find out whether these coefficients that you calculated are correct or not. So there's a lot of engineering which goes into it. And then you check whether this pressure, which it is the hull you have created, will it withstand the pressure. So it was tested in various tanks, both at ISC Bangalore and here. And once this is made, you want to know where the CB, CG and all these components are there. We created facilities for this and we got support for that, and we could, these are all facilities which allows you to do the tests here. Having done all that, then you get to some kind of control formulae which can be used in the vehicle with some, this one for a real implementation. We get all the data from the studies that were carried out, and you get a set of equations which allow us to determine what kind of forces can be generated on the vehicle. And ISC Bangalore and the team looking at the machines that we prepared and gave it to them, and we got it back. It's a very nice interdisciplinary, inter-institute work. They came up with what will be the force in X, Y, and the moments that are acting on the vehicle, and that allows us to know what way it is. So it was implemented through these mechanisms, and these mechanisms had other features that they can not only oscillate in one direction, they can give a directional oscillation and do steering or thrust vectoring that we call. and I'll skip some of these. They did all these studies. This is all the outcome of the studies they did at their end, and they found out what is the most optimal configuration which will allow you to do a good propulsion. This is the same video which we saw there. Then we combined all of these through mathematical models together with lot of equations coming into it, and hydrodynamics, hydrostatic, the forces acting, added mass and drag forces on it, and then you could then enable the control and navigational features which were implemented in through hardware on both the prototypes that we have. The prototypes are slightly different, and these were part of our whole process of doing this thing here. And currently the second prototype is our most active prototype, and everyone loves to work with it because its capabilities is much better than the one. All our students also love to work. The most recent trial of it happened, several trials ago. We now have close to 100 trials and data for all of this, which is very valuable to gain insights of how these can be developed. And this was carried just in the beginning of this month here. So this is prototype version 1. It was readied in December 2023, and several trials of this. It went on all the way up to May 2025. Then the version 2 had trials which are going all the way up to this year also. These trials were carried out in a tank which is there in the ocean engineering department, a new tank coming up there which they call deep and shallow water maneuvering basing, in which you can lower into this, and we have a slightly more space to work with, and you can do the things. The controller architectures, I will skip some of these. There are a lot of controls involved in it, and I believe there are videos here, no? Are there videos? The next one? Okay. So this is how the various modes, at every time we do a test, we capture videos, we ascertain our data matching with everything, and we get these with all kind of cameras, including drone cameras, etc. And the test result will reveal what happened. The data logged in tells us how effective was the trial that you did on it. Okay. So these were trials which were trying to do a depth control and straight line heading thing. And while we were doing that, we actually noticed there are certain things like what is called as a porpoising, where a fish can go up and down with a pitch angle variation, and also a depth variation which matches with that. And that porpoising phenomena which some fishes do, they jump out of water and get in, they can do. It's actually found in this model also. We could actually replicate it. But then it's not nice for some naval applications, so we found a way how to stop that also. So to stop that, again, good control way. Our control engineers here facilitated how to suppress that, and you could actually do with porpoising being controlled in it. And then eventually we were able to do yaw and depth and other control the way we want. Having done this, we could then take this to our, here are some videos just to show our, this is not in this one. This is a typical how a porpoising thing happens, okay, when this is moving inside water. Okay, the fish, when it moves and it's oscillating, the tail flapping is not visible here, but it is going up and down when it is doing a meandering operand. We called it meandering this as well. I'll skip through some of this. Yeah, there was another thing that we could do with this which was very unique. This fish can not only move forward, it can also move backward, which other fishes do, and we figured out how to do that, and I think there are parts of this video which shows that. The fish can go backward also. You will see this going backward with using of other this one. It can actually move the fish backward in a very slow pace. Okay, it is slightly inching back in its orbit. And this is a tank which many people have been seeing around in the lab. A lot of real fishes are there, but actual purpose was to make this artificial fish move. See, it is actually moving back in it. So this can reverse also. It was Nobody thought we could do this earlier, but yes, we could do it now. Okay. You could actually turn it also around, etc. Lastly, I think I am coming closer to the end of it. I do not want to come between you and lunch again, as I said. We had the pleasure when we were told we had to show it to a lot of NSTL engineers, show it to them and say what this product, will it be effectively usable by them, do they understand what has been done. So we had to take it to them to see, let them see what it is and see whether this is. So this was done in one of their, they call it as SMB, Sea Keeping and Maneuvering Basin, and there is a beach through which it is launched. This is an artificial beach. Atanu Jana is here, he is the person who launched it from there. Most methods didn't work there. So this is a trial run in that one. Thanks to them, we got these videos just in time for this presentation here. You will see how this was launched. When it is at the surface, it is generating waves at the surface, but once it submerges, that what we call as Kelvin waves vanish. Okay, and it will they maintain that in such a way that you can see it clearly, and now it is submerged and it is moving ahead, and that's a flexible tail. This was done from atop. This picture was taken from atop the bridge which is there. It is going. It is dived up to about 1.5 meters depth. Was it 1.5 or 2 meters depth? 1.5 meter depth it went, and then it finally comes out. That's a programmed profile, and it comes out at some phase, goes in a fairly straight manner, and the whole team is waiting aside on one side just to see that it is. And now it's surfaced, and there it is. It's done its mission. Okay. There was also a camera. This, I think I'll take this one. This is more interesting. Is there sound coming? This was to capture the sound. You hear the sound of how this. Some of these sounds are that of the carriage, so they are not from the fish. It's all very low light. They had to switch off everything there. Everything. This video I showed because we wanted to show the sound. This is the most silent part of it. Once it dives in, very, very silent. Sonar can detect the shape maybe, but the sound I am not sure. They are going to give us the character. They are yet to tell us about that data. Fishes also make similar noise, but you can't say that it's a. There is some, but they say they could not capture that. They are yet to give us the data to say how accurate it is and all. We got this just. Okay, so that's the kind of silence it maintains. I think this will be the last video which I'll show and leave it at it. This is a launch video from the side where it is, and in this video they were, I think, capturing the sound profile also by hydrophones, which the data will come later. And it is launching this. I think I don't need the sound here. There's a lot of background sound we have been discussing. The vertical line you see here, there is a hydrophone put there. It's trying to capture that sound internally once it goes there. Okay, this is more professional sound capturing device they use. It will dive. Once it dives, all those waves will vanish, and then the real quiet mode starts. Okay, and only visually we can track it because the water is clean. It's just going. It's there moving here. You can see that we have some light. The colors are so chosen that it should be visible. That's the, it goes through these two are the hydrophones dangling there, and they are capturing the data also. So a trial like this was so much feasible just because a very good cooperation got set up between the IITs, ISC, and DRDO lab. It's a different kind of a what you can say experience that we get, not in the labs in the institute, not just anywhere. It is a completely different kind of an experience that you get from this kind of activity. So that's the ending part of it. We are trying to go to the next steps to see what other benefits we can get out of it, and I am thankful to many people who came and witnessed this. This is the first time when the DGNSM came in 2023, and when the trials were conducted in the ocean engineering department, the teams were present. We had a lot of monitoring people also coming and watching these trials, including professors, retired professors, and experienced people in this. This was when the most recent trial was carried out at NSTL, and we are thankful to that. We could exhibit all these and also test these partly in the setups there. Many people from there witnessed this, and they all gave suggestions which are very useful for it. So in future we are thinking of how to upgrade and add more things to it in subsequent activities. I'll share some of this one for it. We want to do away with the way the conventional computing is done inside this. We will be trying to implement neuromorphic computing inside this. The fish brain should be like not our von Neumann computer brain. Okay, in fact, that consumes more power than the propulsion system. We found that. Okay, and already a scholar is assigned to that, and she's working on it. So like this, these are not only usable for fishes, but also for using in other kind of things where vision becomes valuable, and it's coming up for humanoid robotics also. So with this, I'd conclude my thing. I think I overshot a few minutes. Thank you everyone for the patient hearing, and I would like to thank DRDO for giving us this opportunity to do such a project.
Thank you, sir. Can we create a digital twin?
We have a numerical twin already. The digital twin comes in two modes. You can have a full numerical twin. An AI/ML twin of it is being built with all the trials that we are doing, the data that is collected. Everything is preserved in such a way that it will become the one which is required for AI/ML purposes also. That's where that will be closely linked with that neuromorphic computing. So that's the target which Swastika is visiting.
So to scale up and use it for actual applications, let us predict that behavior, what behavior it will have based on your model of So that accordingly we can launch a next project.
Yeah. And we want to see, this is shape dependent. Different shapes will generate different. So we proposed wherever we conduct trials, we'll collect the data and ensure that those models get learned and trained and learned for different. We should be able to predict. Eventually in the sea, you do not know what shape is moving through. So you should be able to predict that also. If stealth is ever, you may be attacked also by stealth. You need to know what shape is coming through. So it's a interesting, but I think a lot of data to be collected. So these are new learnings which are coming out of it.
Thank you, sir, for your wonderful, insightful presentation. Now we have a lunch break at second floor TGH building, and we'll come back here at around first floor. Yeah, first floor.
Oh, this same place, no? Yeah.
Huh?
This is first floor.
No, lunch is in the TGH. Achha, TGH. TGH first floor. Sir, आपका pen drive.
Thank you. I forgot to introduce my team. Divakar is here, very active member for it. Yes. Then where is Vidit? Vidit, the controller behind everything. Atanu was here, and these are the active members other than the faculty. Professor Nagarajan, Professor.
Good afternoon to everyone. Welcome back to the afternoon sessions. We now invite Dr. Sambhunath Nandi to deliver the next lecture. Dr. S. Nandi is a scientist G and head of the underwater robotics and autonomous system group at CSI CMRI with nearly 29 years of experience in advanced robotics. He earned his PhD from IIT Kharagpur and has led major national projects on autonomous underwater vehicle and robotic systems. He has published extensively, hold patents and copyright, and has mentored BTech, MTech, PhD scholars. He also served as a professor at Academy of Scientific and Innovative Research and has contributed to the academic program at IIEST Shivpur. Currently, he leads the initiatives under the Deep Ocean Mission and serves on important committees of CII, DST and DRDO, contributing to the national science and technology initiatives. I warmly invite Dr. Sambhunath Nandi to kindly deliver his lecture. Sir, please come on the dais.
Hello, hello. Am I audible?
Yes, sir.
Yeah, very good afternoon, and I hope after lunch, the participants, they are yet to come, but still due to shortage of time or time schedule, we had to start. I especially convey my sincere thanks to Professor Das for inviting myself and CMRI team in this forum. I am also thankful to all the team members, particularly NSTL, then DRDO, DFTM, Technology Management, then NPOL, whom we have met, Professor Mukherjee, then IIT Kharagpur team, Professor Kumar and team, Professor P.V. Sujit. Somehow we met sometime anywhere else, and we are a known circle. So I am glad to be here. So my presentation will be in the domain of unmanned underwater vehicle design, navigation, guidance, and control challenges and future trends. So in the previous sessions already, NSTL director, then Professor Kumar, they have already touched upon some of the things which are very pertinent to underwater robotic systems. So I am working in this area since 2001 almost. So initial contributions was from Ministry of Earth Science, the then DOD, Department of Ocean Development. So that time we had a project of under PMN program, polymetallic nodule program. So under that we have developed ROV for 200 meter depth in 2001. So at the sea trial was also from coast of Chennai with active support from NIOT, National Institute of Ocean Technology. So it was a very encouraging experience in that time, spending around 7 to 10 days in a mid sea and going for sea trial. That's very challenging activities and also very tough. Unless somebody is in the sea trial, that kind of feelings will not come. And of course, it is a very challenging and demanding task in the current scenario what is prevailing throughout the world, and India also should come up to develop that kind of capability for underwater system development, so that we can have a strong strong barrier in the domain of, a strong defense sector in the domain of underwater robotics, addressing the need of submarines, underwater vehicles and so. Next slide please. So already slide changes from here, no? So, underwater robotics is no doubt is a multidisciplinary field, and it is also fact that scientists know more about the surface than the moon than the depth of the ocean, and it is very difficult to conquer the inner surface than the outer surface, because it is a GPS denied environment, and navigational sensors are very much error prone. To get a AUV, or I mean to operate an AUV in that particular domain, navigation is a very challenge. I used to ask this question, that how many of us in India has tried a AUV? Suppose releasing the AUV in a particular location, and again taking back the AUV in the same location. How many person in India has done that kind of activities? So that is the first challenge we have to do in navigation. Okay. So navigation guidance and control is a very challenging task. Of course, we are lacking the hardwares, particularly in the field of actuators, sensors, and we have manufacturing capability, but sensors and actuators normally we used to import. We have software development capability, we have navigation guidance capability, but that basic the platform should have that capability to embed upon it the advanced features in terms of AI, machine learning and all this. So that is my humble request to everybody. So let us first prove that AUV is capable of navigating in a unstructured environment, not only on the surface, because surface GPS is there, but in underwater environment it is capable of moving at a particular mission, again coming back in the same location, we are able to retrieve it without any external support. So that is the first channel. So the challenge, of course, it is known that our sea depth, average sea depth is around 6,000 meter, and somewhere it is 11,000 meter also. So but 90% of the sea depth is covered under 6,000 meter, and pressure becomes unbearable for humans after 30 to 40 meter of depth, and it is very much necessary to develop these underwater systems in terms of autonomous underwater vehicle or remotely operated vehicle to help the divers who are spending their, who are sacrificing their lives towards doing the inspection of sea falls and other requirements. So there is a huge need, but the beliefs was that in 6,000 meter light is not going, how the some miniaturized objects or plants or fishes, they are surviving in that environment. So it is the fact that only 8 people have reached Challenger deep, that is the 11,000 meter depth, but in space we can see more than 550 people has traveled. So obviously there is a challenge, that is why there are lot of restrictions and people are not able to move. And if you see the development, it took place from initially the ships, people travel from one place to other, then submarine has been developed to mitigate the warfare, particularly during Second World War, and that is gradually getting advanced and advanced. People are trying to get stealth submarines, that which will be which will have very low signature, so that others cannot capture, and it should have some surface which will not reflect anything. So that kind of features current submarine demands, as well as it should have high endurance, all these things. Then manned submersibles, this is also an important development, and Alvin is the first manned submersible that is developed by US Navy, and then ROV, remotely operated vehicle, which is a kind of underwater vehicle where power and signal both are communicated or both are transferred to the umbilical cable. And then next one is autonomous underwater vehicle, so where it's a tetherless, and power system as well as intelligence both are embedded on board. So these are classification of AUVs, already it has been discussed. Classification of ROVs, pure observation class vehicle, observation vehicle with payload, work class vehicles, towed vehicles and specialized vehicles. Then AUVs also it can be classified up to shallow water, mid water, deep water and all this. Okay, and it might be thruster driven, it might be control surface driven, and some may have limited endurance, some may have endurance up to 10 days or so. Currently, as NSTL is developing HEAV which can stay at sea up to 15 days of time. Unfortunately, I am the part of that review committee of that HEAV. So here these are the challenges for underwater technologies. Inner space is difficult to conquer, and it's a dynamic medium, hydrostatic pressure, density and salinity variations, temperature variations, corrosions, absorption and EMI radiation, and solution is nothing but the underwater vehicles, and we are looking for that. So, these are the design requirement, freezing of the tentative specifications. So, what will be the maximum velocity of that vehicle, what will be the maximum acceleration profile, that is also required, otherwise you will not be able to estimate the power of that thing, because velocity, constant velocity means it is a steady state requirement. So, that we can fulfill. Then compact, lightweight and modular design, then design for strength and rigidity, design for minimum hydrodynamic drag, then near neutral buoyant system, robustness and flexibility, selection up to appropriate payload sensor and navigational sensors, then bidirectional communication, these are one important area, high quality data and efficiency, operational reliability, real time data monitoring, redundancy, health monitoring and emergency handling. These are very important design requirements. So, this is the class of vehicles what CMARI has very recently come across, like AEV 150 we have developed from the funding of Ministry of Earth Science, and we have tested the system at Chennai coast. Then ROV 500, so that is also developed from the Ministry of Earth Science funding, and then we have come across with the AEV 500 that has been developed under 12 5-year plan under CSIR funding, Council of Scientific Industrial Research, and I belongs to CMARI Durgapur, and we have developed that, and we are in touch with L&T and Bharat Forge for technology transfer. Bharat Forge has also got they are taking some technology of AEV from CMARI. Very recently they have paid the money also. We are yet to transfer the technology. So, these are the possible application areas of the underwater vehicles, like underwater exploration, survey, mapping and bathymetry, inspection of dam, volume mappings, ship hull inspection, cleaning, archaeological survey, environmental monitoring and all this. So, this is the AEV 150. This is a small video which is embedded here. So, this is AEV 150. Initially, we have tried at our shallow basin. We have a facility of 50 meter long, 10 meter width and 5 meter depth at our CMARI center, and there we are doing our primary trial. And for this vehicle, initially we visited Idukki Lake, Kulama. And so this is the video sound, I think. And then we went for sea trial from the Chennai coast with that ship that is the Sagar Navy. So this is the specification of AEV 150. Length is 4.8 meter, diameter is 0.5 meter, weight in air is 490 kg F, and buoyancy is 495, material is aluminum 606 on T6, and battery is lithium polymer battery. So subsequently we did the sea trial with that AEV 150. This is the ROV 500, that also we have tested at our shallow basin, then open water body, then we went for sea trial at Chennai coast. This is one of the video of that. Okay, let me forward it because time is short. So this we have tested up to 500 meter of depth. This is the depth, GUI, where from we can see that ROV is achieved a depth of 500 meter. So then we have developed AEV which can go up to 500 meter depth of operation, 500 meter depth. So in our AEV 150 we have used all 5 thruster configuration, but here it is a hybrid configuration, 3 number of propellers and two dynamic control surface. So that we have used, and we have controlled that vehicle in that manner. So this is AEV 500 sea trial. We did it from coast of Goa with the ship from NIO Goa, because we have NIO was also partner in this project, but they have no contribution in this AEV 500. They developed seabed resident event profiler under this 12 5-year plan. So this is AEV 500 sea trial at coast of Goa, and you can see that GUI as well as acoustic communication framework that is being used here. So this is another portable, remotely operated vehicle with manipulator for minor inspection and intervention. So you can see that video which has been, we have a small pool at our office. This is very small pool apart from a 50-meter pool also. So there is a small pool, and with this manipulator we are just handling the job. This manipulator is indigenously developed. We have used Maxon motor, and this actuators, sealing and other things we have our own, and it's a tooling manipulator. So, and it is able to carry the object. It can pick up the object also from the surface, so through image processing. So this is the small ROV, and then these are the team capability of CSIRC, MRI design, analysis of robotic system, power, energy and system design, hydrodynamics, CFD modeling, RF acoustic and hybrid communication framework, advanced controller with obstacle avoidance, navigation guidance and control. So this is typical scenario of how AUV is working. From the ship we are deploying it, and then AUV is going for some mission, and it is the communication is happening with that acoustic framework. And there are limitation of acoustic communication, particularly the bandwidth is very, very less. So that's why nowadays people are also looking for to develop optical communication. This communication framework, it is also embedded with a modem. It's a USBL, ultra short baseline system, so that we can have communication as well as data transfer, both the thing. So this is AEV 150, some of the pictures how we have designed this system. It's a modular in base, nose module, thrust module, power module, okay, computational module, tail module. So this vehicle has 5 propellers, and one tail, 2 vertical and 2 horizontal. So with that we can control 5 degrees of freedom, and roll we are not controlling actively. So that has been mechanically balanced, so that if there is any disturbance in roll direction, it can come up to its own. So these are the overall architecture of the sensors. It's a lithium polymer battery, Doppler velocity log, then tunnel thruster in vertical direction, tunnel thruster in horizontal direction, 2 numbers, then one tail thruster, then acoustic modem, pressure sensor, GPS antenna, tunnel fins, forward looking sonar for obstacle avoidance. So this is the generic dynamic modeling. So I am just trying to make you understand that how a AUV system development took place, starting from its design to dynamic modeling, control, then sensor fusion, and then mission planning and all this. So this is the dynamic modeling in general. So there are inertia force, then centripetal and damping force, then gravity force. This is equivalent to generalized force required to provide motion in different direction, particularly surge, sway, heave and roll PCO. These are the 6 directional motion we used to perform. So these are the hydrodynamics. This is very important to get the idea what will be the requirement of thrust for various actuators which are embedded into this AUV in various directions, particularly surge, sway, heave as well as rolling motion, roll, pitch and yaw. So and this drag we have also calculated with different angle of attack, and we have found out for that particular length and for that particular diameter. So what is the velocity versus drag plot, that is also shown here. And if there is whatever design we are making, there is a possibility of vortex generation, or it is a smooth streamline motion, that also we will be able to address through this hydrodynamic modeling. So then in some cases we are using control surface so that some control surface power requirement is less compared to thruster based actuation. So in that case, how to calculate the area of that control surface, what will be the power of that control actuators which will be fitted with the control surface, that also need to be calculated, and this is very important to provide the required maneuverability of that autonomous underwater vehicle. So these are the different coefficients which we have calculated from the hydrodynamic modeling. So different hydrodynamic derivatives which are very much important to develop the controller for this autonomous underwater vehicle, which has been developed for 500 meter depth of operation. And also we can find out what is the minimum turning radius of that vehicle, that is also important. So whether it can take spot rotation or whether it can have some turning radius, that kind of prediction is required, and that we can do using some software simulation. So then we have to do the stress analysis, because for 500 meter depth of operation you are understanding that pressure is 50 bar. So at least we have to go for 1.2 times of that 60 bar pressure. We need to check that rigidity, stress and strength and all these parameters for the pressure hull, because the pressure hull is a important part of autonomous underwater vehicle, because all the embedded electronics including a battery that are placed inside that pressure hull. So that's why it is very important to do the stress analysis, and if there is any shortage of if there is any discrepancy, we need to look into that very carefully. So these are vehicle control systems. So this is most important thing is precise navigation, autonomous control and advanced sensors. So here as we said that it is complex than the aerial medium. So moving in an underwater medium is always complex, and it is also GPS denied environment. So we have to come up with some methodology or some algorithmic framework so that we can reduce the CEP, that is circular error probable accuracy, and we can go ahead with that right track. So this is very important, and probably those who are working in this area, they know that a very costly INS, inertial navigation system, it costs around nowadays 3 crore. And if somebody is using a low cost navigational sensors like IMU, DVL and might be when it is surface, GPS also can be a part of that for initialization. So that kind of sensor with algorithmic framework, then it is also it will have very high demand if we can achieve similar accuracy what we are getting with that IXIA, that photonic INS system. So that is very much important requirement for the current scenario. So precise navigation is very important. Then we have autonomous control, that is real-time adaptation, and advanced sensors. This plays a very important role for multimodal integration, that is the part of sensor fusion. So INS is giving some redundant information, DVL is giving some redundant information, GPS is giving some positional information. Then how to combine that information, because we cannot believe that all the data are correct. So we need to have some fusion mechanism so that we can get the best possible estimate of the system state. So this is the control system architecture. So this is the guidance, navigation and control. So we should have clear understanding about this thing. What is the guidance, what is navigation and what is control. So guidance is, navigation is from moving from one place to other. Guidance, how I will move from place A to place B. So this is the part of guidance. And control is low level actuation commands and stabilization commands that needs to be given to the actuators. So this is the control. So that guidance, navigation and control framework, this is very crucial for any autonomous underwater vehicle. And of course, it is an integral part of mission planning, that is high level objectives and waypoint generation. So then we will have inertial navigation system like IMU components, then performance matrix, navigation function and all this. So this is a generic control framework. So there are desired trajectory, then robust controller, then thruster, it will generate the thruster voltage, then it will go to this actuators of that autonomous underwater vehicle, and then sensor will measure the position and velocity of the vehicle, and then it will be compared, and accordingly the equivalent control input of that error will be provided again. So there are different control control methodology like PID controller, dynamic feedback generation methodologies, sliding mode controllers, and other robust control methodology. Even for state estimations, sometimes we are also using Kalman filter, and for obstacle avoidance we are embedding the fuzzy logic. So these are some simulated trajectory profiles like lawnmower motion, how a AUV will start and how it will go for a particular lawnmower profile for survey. So this kind of simulated trajectory profiles are also very important. So here we have also carried out zigzag motion with that AUV 500, and then these are the sensors what are normally used for any autonomous underwater vehicle like IMU, inertial measurement unit. IMU with Kalman filter, that is nothing but the INS, inertial navigation system, and Doppler velocity log, depth sensor, altimeter, then GPS is for the surface for initialization, camera, ultrashort baseline system, then side scan sonar for survey, forward looking sonar for obstacle avoidance, then conductivity and temperature and depth for seabed, sea column mapping. Then these are sensor fusion perspectives. If AUV length is around 5 meter and different sensors are placed across the AUV, then we need to have a proper transformation for each sensor. Like INS is placed in particular location and DVL is placed in another location, then we should have a proper transformation to map the position of the AUV with respect to the global frame. And also we know that different sensor is having different frequency or sampling rate. So that's why we need to have proper attention when we are combining the multi-sensor data. So these are very important. So transformation from various frame to a common frame of reference. So this is sensor integration and data fusion framework, multimodal sensor processing. So Kalman filter is one of the possible tool. Then there are with multiple sensor shoot like IMU, DVL, pressure sensor, magnetometer, okay, and fusion benefits in redundancy and fault tolerances, improved accuracy and reliability, and real time uncertainty estimation. And communication, already we have also used some communication, but communication is also a major bottleneck in this area. So till now, in underwater acoustic communication, if you see the velocity of sound is around 1200 meter per second in water, and in that case, if you are operating a vehicle at 6000 meter depth, that one signal whenever it will come, it will be more than 5 seconds. Okay, so that is not expected. We want that whenever a vehicle is moving in an underwater environment, we should get the information at least in every second. So that is very important, but that is not happening due to this kind of limitations. So that's why there is a very huge, very challenging requirement of development of this kind of communication system. Even if we are that kind of things are available, but there are lot of restrictions to import that kind of product, particularly from Germany or USA. That kind of acoustic communication system importing is very challenging, and lot of declaration you have to make that you will not be using for Indian Navy or DRDO and all these kind of things. So these are AUV 150, some of the pictures that we have developed the trials, some of the report, and lawnmower trajectory what we have followed in Iduki Lake, then 8 meter depth stabilization, 80 meter depth stabilization, roll and pitch plot, then some of the lake trial videos, then 150 meter depth qualification, and then you can see some graph where AUV is going an 81 meter and doing some trajectory. So this is a video captured during one of the mission at Iduki Lake with that camera. So then we at CMERI we have a multidisciplinary expertise. So particularly the requirements are hydrodynamics, then kinematics and dynamics, then stress analysis, design of the autonomous underwater vehicle, then post processing of the data, then robust control of the AUV for mission planning and navigation guidance and control, then actuator calibration, sensor calibration, modeling and fusion. All this overall we have a comprehensive idea of development of autonomous underwater vehicle. So currently we are doing some, as we said that whatever development took place till now, most of the components, particularly actuators and sensors, are imported. So recently we have taken some initiative that why we are not able to develop a thruster. We have taken one initiative to develop a thruster which can go up to a 1000-meter depth rating, and it is 1 kilowatt power. So probably some of you are using Techno9 thruster also, 1020 or 1040 model. So we are benchmarking that, we are trying to achieve that kind of performance. We have some funding from Ministry of Earth Science and a Deep Ocean Mission, and we are developing this thruster. So some preliminary trial we did, so this you can see at our small tank here, and we can achieve up to 60% of the performance. There are some problem of this power system, power MOSFETs is getting heated, and some problem we are facing. We want some industry interface to improve this also. So then we are also executing one project on sensor fusion algorithms for underwater systems. Currently some field trials are going on in that area also. You can see there is a small surface boat. There we have mounted very low cost IMU and low cost DVL, then RTK GPS and compass, and with that we are doing surface operations, and we are whatever algorithm we have developed, with that algorithm we are trying to see the post processing of the data, and what has been advised also, and we also need that. So without GPS, if we cut the GPS and if we run with the sensor for a particular trajectory, what kind of trajectory we are getting, what is the error we want to see in the real time, that kind of experiments we are now carrying out. So this is a very important component, sensor fusion algorithm for underwater robotic systems, and once it is succeeded, we will be able to use it for our own autonomous underwater vehicle also. Then we are doing one project, inspection and intervention class AUV underwater robotic system. So this is a remotely operated vehicle, and particularly this one you can see. So this ROV we are developing for sea file inspection. So this is one of the project we are doing now, and actually that real frame is not yet developed. This is aluminum alloy base. So this is a test bed prototype, and we are testing it at our pool also, and it has the capability of measuring up to 30 meter of and not 30, up to 70 meter of hull thickness. Minimum thickness is 5 millimeter. So that kind of work also we are doing. So it is a ROV, and its basic purpose is to use it for sea file inspection. So these are possible future trends and research direction, AUV with long endurance range monitoring, exploration and surveillance. So very recently we have provided some design guidance to Indian Navy to for the XL AUV development, which can stay at sea for 30 days around and for surveillance purpose, and every day it will come up to the surface for updating its position for 3 times. So that kind of one design guidance we have provided to Indian Navy. Another area is
previous slide on the right side bottom, is it a crawler?
No, this is a assembly with magnetic wheel, and it is assembled with a brass and NDT sensor. So that is being fitted on the side of that ROV. So we are facing some balancing problem also, because that's a heavy unit. Okay, it will be crawling on the surface of that sea surface. Like this is the sea surface, it's not sea, ship surface. So this is the ship, this is one of the surface. It will crawl and it will measure the thickness, but vertical and horizontal also. But here the issue is the navigation and the positioning, because this NDT sensor, it needs touch to measure the thickness. There are some other methods also that we have not applied yet, but we feel that instead of doing this, it will be better if you go for eddy current based some methods. So that will be more appropriate, but that is very costly also. Okay, now currently we are doing with NDT sensor based, but positioning, so suppose there are hundreds of grids, which one you are doing, that is very important. with respect to one corner of the ship, which surface you are doing and which grid you are doing. So, that is very important, otherwise the measurement will have no meaning. So, that also we are establishing. Yeah. Yes sir, just 2 minutes sir. Then these are the areas, the multi-vehicle cooperation for various application, that is wide area surveillance, I mean it is a multi-agent system, hybrid underwater vehicles. So, this ROV we can run in autonomous mode also, and we can use it with cable to see the video at surface. Then autonomous intelligent class surface craft, UAV manipulation intervention system for inspection, repair, cleaning, thruster sensor for communication system, thruster sensor or communication system development, these are the requirements. So, we have started developing thruster also. So, unsupervised scene modeling and anomaly detection, then AI ML based intelligent algorithms and big data handling, secure communication in underwater environment. These are very important futuristic areas. In that futuristic area, we have done some expert support and guidance towards design input studies for extra large unmanned underwater vehicle for Indian Navy. Then underwater robotics data driven design approach. I mean, why I have put this slide, because we are talking about data, AI, ML, all this, but what is the utility of that? For that we need to have first a very well proven platform which is available. With that only we will be testing that framework. So, in this case particularly currently we are doing a project which is known as this homing and docking. Okay. So, homing docking is a proof of concept project we are doing for Ministry of Earth Science. It is a proof of concept, this is not in the TRL level high, not so. So, here what we are facing, that in that dock, if it is a funnel shape, which one is front side, which one is back side, which is left side, right side, to identify that. Because if this is the dock located here, AUV might be here, AUV might be here, any quadrant. So, AUV need to understand that okay, this is the front side, this is the back side, because you are doing some acoustic based localization. So, in the shortest path you can go there only. So, we need to understand the AUV, okay, this is the door, you go there. So, for that this AI driven framework we are also using. We have collected lot of data of that dock, okay, maybe 10,000 of data of each and every phase in different distances, and we have trained the model and we have tried to understood that dock AUV, that this is the front side, this is the back side and all this. Okay. So, this is there are different challenges in this homing docking project. Reach a safe positioning zone, switch from obstacle avoidance mode to dock mode. Then you may use electromagnetic or camera based image processing for acoustic positioning, all this dynamic stabilization and approach towards docking platform, and then dock with a help of a mechanical this. So, these are the development already being taking place at our place. We have made a dock of this is the funnel shaped dock. Okay. So, this is around 3.5 meter height, okay, this dock what you can see. Now, this dock we have deployed in Maithon Dam, okay, and we are doing we have collected huge data for this, and we have made a machine learning model through which we are able to understand this is front side, this is back side, this is left side, right side. And currently we have made a small dock also, because procurement in government sector is taking lot of time. So, we have used very small propellers, we have used a small AUV and a dock. I think NSTL has visited, Dr. Das and team. They have also seen our thing, and probably your director also seen in through video. Okay. So, some primary that docking, AUV maximum dimension is 600 and dock dimension is 800. From any position we are able to dock the AUV inside that. Okay. Now, we will be adding this wireless power transfer over that, and we will be doing the charging. So, wireless power transfer with very minimum level also we have achieved now, and that we will be interfacing with our small AUV, and we will be trying to achieve that. So, this is at our shallow basin. You can see that AUV is moving and it is trying to dock inside that docking platform. So, that is the AUV which will be coming up now. So, that is under fabrication, that corner one. But as the procurement is taking time and manufacturing is taking time, we have proved our concept with a test bed AUV and a dock. Yes, this is the dock, and you see AUV is entering inside that dock. So it is hanged from two floating buoy. Okay, this is another how a machine and human beings can speak to each other. So this is conceptual UHRI framework. Like one diver is operating in underwater environment, we are sending one AUV and ROV, and suppose if diver is feeling that okay, there is a requirement of lighting in that area, or you help me to pick up some of the tools which has fallen down. So in this framework we can do that. Okay, so thank you so much. I am at the end now. Thank you.
Thank you, sir, for your informative sessions. Our next speaker is Professor P.B. Sujit. Dr. P.B. Sujit is Professor and Head of the Department of Electrical Engineering and Computer Science at Indian Institute of Science, Education and Research, Bhopal. He obtained PhD in Aerospace Engineering from IISc Bangalore in 2006, MTech in 2002, BE in 1998. His primary research interest in the building of autonomous air-ground sea vehicles, multi-robot system and human swarm interactions. With great pleasure, I just invite Professor P.B. Sujit sir, please take in charge. Just a minute. So this is your phone. I'll So in this talk, I'll just give a glance of different AUV applications that we have been working on, and a little bit of AUV and ASV also. I'll just try to give a touch up on this. So currently I'm at IISER Bhopal. So I think many of you don't know that this will be my outline, but many of them you don't know that IISER is typically sciences, but only in Bhopal we have engineering. So that's the reason I just put it one slide on just to know that there is an engineering, and we are actively looking for in the faculty and good students out there. Yep. So as an outline, so we'll look at, since there have been already a lot of discussion about the requirements for underwater vehicles and everything else, so I'll just directly dive into some of the work that we have been doing, and we have something that we have done. One is on, let's say that the very AUV that even Dr. Nandi just now said, like we need to deploy first. So to deploy, there is a lot of time and effort and learning that goes, right. So before going there, you want to learn, or you want to make sure that everything that you do before going to the field is at least to knowledge it is working well. Yeah. For that we need to do some kind of an SATL, which is your software in the loop. So to do that we need to do several things, right. So one is we need to do a mathematical model of the vehicle, and some of the many times we do not know the model itself, because it's, when we start the project or something like that, you know that parallelly the actual construction of your AUV also starts, right. So for startings we take what is available in the literature, we will try to make the model and then tune the parameters such that you can start to look at how the revised model that is from the field gets into it. Here what I will show is the project that we did with NSTL for their AUV, where we did the mathematical model of that, and then we did the controller design and based on the mathematical model, and then do you simulations, at least first initially on the MATLAB, to see that if everything is working well, and then you need to get into the actual physics of it, right. So wherein you want to simulate the water currents, the effect of acoustic signatures coming from USBL or LBL, whichever you want to use, and this the entire loop. Okay. So the entire loop of a controller design, simulation, and the simulator, this keeps on getting iteratively over time. Yeah. And finally we will come up with a good system such that it is as good as close to the field. You do field tests, again there will be some issues with your controller, again you have to come back to the drawing board. Yeah. So that is what we did here. So this is a kind of model for this, the AUV of NSTL that we used, and then we designed the controller for this. So this is the depth controller, and then there is the speed controller, simple PID, but it still reasonably works out, and some yaw controller to make sure. So with these three controllers, the objective was to make sure that it is actually going to the desired depth, and it does not do any kind of a rolling motion while pursuing its desired waypoints and circular patterns if there are. So these are some of the results with the simulation part, and then I will just show with the actual thing that has happened. Here is the depth of it. So it's showing that like this was for an 100-meter depth, for which we can see that it is actually going, but this is in the MATLAB side. Yeah. So when I go from here to the getting into the physics with a ROS gazebo kind of a simulation setup. So okay, this is one of the setups where we made sure that we put everything onto a single Docker system, so that anybody who wants to use in the NSTL, or anybody, the new learners who are going to come, everything is there, and then they can just use it as a starting point rather than now getting the new libraries and everything else. And some of the stuff are typically on Python, and any one change in your Python version, just you can't use it at all anymore. Yeah. So that's the one of the things that we did, and the next one was to show that the NSTL AUV can actually perform trajectory and waypoint following. So these lines, what you have is the side scan sonar from the gazebo plugin that we had, and the DVL sensor on which we can get the reasonable amount of the velocities that from the simulator, which we can use it in the design of the controller, performing certain pitch and diving scenarios. Yeah. So you get a lot of cameras. So you know the many of the times you want to see what is going on underwater. A good thing is to use apart from the side scan sonar or the forward looking imaging sonar, to have some cameras. So even not just only for doing any kind of a mine operations, but even for doing ecological survey or any kind of a ship kind of a wreck, it will be nicer to have a much more deeper information rather than the just the side scan sonar stuff. Yeah. So this is the side scan sonar module with the AUV, and then this is the real versus. So this is the actual one of the field trials from which we got the data. So this is the kind of a data, and this is something coming from the SITL operations. So which is closely matching. There will always be some issues which we can always reflect back and then say on the model side. Okay. So, and then we further extended that for now can we do it for a multi-agent system. So, because of these are loss plugins, then I can simulate 4 of them and then give a different missions such that I can do a multi-AUV kind of a simulation which I can replicate back onto the mission planner so that you can deploy multiple vehicles to do any kind of a mission. So, okay, so I will get back to the later part where now most of the mission planners have some kind of a capability for multiple vehicles, but what happens is that you need to synthesize a multi-vehicle plan and then you give it to each vehicle, this is the kind of a plan that you want to do. Yeah. So, so that you can use it for different different kind of applications. You can have a event triggered kind of a system wherein you can actually do it in terms of on the fly. Let us say you have got a frontal image from one of the side from the sonar and then you want to change your path line or you want to map it up and then give it. Okay. So that is where we need this kind of a simulator. So now that since I have one vehicle done, I want to extend the mission to something else. So then we have to do a recharging of the vehicle or get the data from the vehicle, right. So because any kind of a data that you want to get, especially the side scan sonar or the imageries are pretty heavy in terms of the data, right. So either you want to bring it back or you want to if you are within the range then it tries to surface up, you communicate and then get the data. But oftentimes when trying to come back is always going to be a pretty difficult task because your operations you want to be extended over. So one way is that I can have some stationary stations or even I can have send a board from which I can get the data out. Yeah. So for which I will use a kind of a docking mechanism. So okay, so the docking is just one more application for this. So in order to get as Dr. Nadi said, the guidance law is always crucial in this case. So let us look at a very simple case of how we can design one. Yeah. So the typical, since I am from aerospace, I will just take a missile in the target, but now I can even in a naval thing I can take a torpedo on a ship or whatever. So I have the distance between these two, right, so which is nothing but my r. Yeah. So now instead of looking at the Euclidean space, I will look at the relative vector space. So Vr, which is nothing but my relative velocity at which the distance is changing, which is d dot, right, and the theta, which is nothing but my line of sight distance. So that will also change as the target is moving away, it is maneuvering it. So I have V theta. So if I look at in V theta and Vr space, right, so this is the kind of a trajectory that I can pull it up, how it works. I have 4 equilibrium points. So 1, 2, 3, 4. So if you look at this point A, right, here it says that Vr is negative, which means that these two are coming closer and closer. Yeah, and V theta is 0, which means that they are not rotating over space. So they are coming over and then trying to come closer, right. So which is eventually it will become 0 because r dot is decreasing over time. So what happens here is 2 things. One, if it is a missile, then you want to impact with the maximum velocity that you want to hit. Yeah. So closing velocity you want to increase at max. If it is a docking, I want the closing velocity to be as close to 0. Yeah, so that you are smoothly entering into the dock. So your relative velocity becomes 0, right. So that is where the docking comes. The other side is the missile side of it, where you want to hit with the maximum velocity. On the other side, if it is here, we are positive, which means that the distance is increasing over time, right. So you do not want to use that, right. Where will you use it? You want to use it where you have collision avoidance. If they are coming together, you want to increase your distance with respect to your target. So I will try to have a guidance law that is more towards my Vr, positive Vr. So it increases the distance and I am going to avoid with respect to my car target. So V theta 0 is nothing but here my Vr is 0, which means that I am constant, Vr is 0, my distance is constant with respect to my target and it is rotating over space, right. So either it is positive rotating, negative rotating, or either vice versa, which I can use this as a equilibrium point for doing any kind of a loitering kind of a munition. I want to roam around a particular given target point. So then this is the kind of points at which I will use.
For controller you are generating
meters or angle.
So for docking?
For controller.
Yeah.
So guidance command you are generating in terms of acceleration.
Heading angles. Which heading angles you need to change?
Question I'll just frame differently.
Yeah.
Are you using analogous to proportional navigation or are you using something else?
Yeah. Okay. You can use any of the guidance laws. Okay. For a docking, you have the speeding profile that needs to be going to the velocity such that it will.
Like control also, you will be
Yeah.
making correction based on either acceleration or in terms of angles, correct?
Angles.
But you are using in terms of angles.
Yeah. Yeah. So for here typically most of the analysis is done at a fixed velocity, but for docking you need to make sure that your velocity also decreases. But as you decrease, your buoyancy starts to kick in, so it will try to pull you up. So and then the depth controller will kick in and then try to bring it back. So you have that dynamics associated with it. We'll see in one of the simulations where we actually see that. Yeah. Okay, something happened here. Yeah. So at the planning, we need to development of a guidance law and then relative speed control profiler. Collision avoidance while performing the dock to make sure that while you're standing from your homing to the time you come, nothing happens to it. Sensing side, you need a forward imaging sonar, USBL for distancing so that you are away and then you know exactly from where your dock is, and you need to take care of the positioning errors because of the acoustic delays, and while you are close by, we want to use a vision in the loop for precision docking so that you are within the particular funnel that as Dr. Nandi has already shown. Yeah. So for that what we do is we use a polynomial guidance kind of a profiler where we use the n dot which changes such that it actually gives you two things. One, how aggressive you want to get until you see the visual and then so that you can slow down, or you want to change it to be a continuously linear by which you can change these numbers to get a nice determined speed profile for the guidance laws. Okay. So this is for something for stationary dock. You can see, so what we are only doing here is on the speeding profile, and you can use any other guidance law. You can use a pure pursuit, you can use LOS, you can use PN. Okay, I think, yeah, so you can see that with this speed profiling you can come to the desired speed profile that you want at some point, and then here you can see that the errors are 0 but it's never a 0, it just roams around that. Yeah, this is for the moving dock wherein this was the starting point and which you want to move around, and then slowly they are just coming on to the desired wheel profiling part. Yeah. Yeah, so this is where we show that you can use LOS or carrot chasing or nonlinear guidance law, which is your L1, true proportion or RTPN kind of a guidance laws, and you can see that all of them they tend to go, they will have a different trajectories because each of them has a different philosophy in which they want to work with, and each of them also need a different kind of information to run, right. For instance, PN requests theta dot with the rate of change at times which may be a bit corrupted more, while other ones like say if I make it like a line of sight guidance, then it may be far better because it is just giving you the direction in which I want to move, but it moves very slow, it is not the optimal one with n is equal to 3 in kinds of a PN guidance. Yeah. Okay, so we did this earlier as shown, we did it with Ross and Gazebo. So then the Gazebo was simulations with respect to the way we were using was pretty difficult to include other aspects. So we tried to move to a different kind of a physics engine only, but still keeping our the back end of Gazebo back end as the Ross framework so that it is easy for us to pull it across. So currently we have done it on a Girona, but the next phase will be to change this to the NSTL AUV that we already have. Yeah. No, so this is one is in Australia. The University of Sydney, they use that.
Yeah, yes, Stanford, Australia, and Spain, Girona, they use this 3-hull, and the Lisbon uses a 2-hull kind of a AUV. Yeah, here is the dock kind of a funnel that very similar to what Dr. Nandi has shown. So here typically you can put lights, we put lights. If it is 4, then it becomes very symmetric, so you don't know the orientation. So we just added one more extra light to get the deviation across, how we can identify whether if there is any kind of an issue with respect to the orientation of the vehicle as such to the dock. Yeah. Oh, this is called Stonefish. It's an open source. Yeah, so you can see that it's never straight, right? So it's wobbling around because of the desired velocity when it comes, then the buoyancy kicks in, and then you have a little bit of going up and down that happens around near the dock. So yeah, so although this is a preliminary, we need to still work on it, but yeah, this is the starting point from where we can do more. Yeah, so if it is required, so we can release the open source, but not with what is there in the project, but else part rest of the things that can be opened up, and everybody else can play around and then design their own guidance laws and things like that. Yeah. Okay, so this is where you can see that on the top view, you can see the way which comes near the part. So there is some deviation which maybe further guidance improvement in terms of now the accuracy of the path needs to be done. Yeah. Yeah, future work is around this, and we want to do the experimental evaluation. But anyhow, so we'll try to get more about it. So this is one for one vehicle. Next I'll do a little bit about how we did for something for a multi AUV, where we want to do some kind of a dynamic, some kind of a process, and how we can use for multiple vehicles to map this kind of a process. So although it's a DRDO workshop, but you can make although it's an oceanography, but you can make some other target which is very equivalent, but you can use similar ideas around. So one is like, let's say that these are the kind of processes that are there, and I want to map them to the desired accuracy, desired resolution. However, there is only one catch, is that I can have faults in the vehicle. So which means that if I use for 4 vehicles or 5 vehicles, I will lose 2 of them because of something or the other. At least let's say that there is a fishing net and then these carts, I can't use it anymore. So then can the other vehicles recover the rest of the 3 vehicles paths, such that now I can change their area of coverage so that they can cover everything else. Yeah. So that's the entire idea about using. So in order to sample these areas, I want to use some kind of a adaptive sampling, so that I can sample more where I required, otherwise I can just keep changing. So the question is, how do I sample? In a traditional way, I'll just put lanes, I'll ask the AUVs or make them into pieces, and then I'll give it to them. So these are the default parts, but some critical information within these lanes that can be missed out. So what I actually want is that I want to make sure that I have much more higher resolution over here, and then I can go into my default path in the rest of the places. Yeah. So question is how to deploy these agents, quicker area coverage while ensuring that I have a fault tolerance. So one is, since I have a multiple agents, then I can just give one this area, other area, and other area, so that I can cover it up. So that is the optimal. But because of faults, I need to get into that. So let's say if it went up to half, then now things get wrong, and which means that after finishing everything, I'll say that okay, fine, now this vehicle is gone. So now I need to deploy a new vehicle to cover the existing the leftover area. Yeah. So this is how. So what we want to do is a bit different, right? So what we want to do is that we want to deploy it in an opposite direction in the same lanes, such that I'll put 2 vehicles in opposite direction. One vehicle is starting from here. Yeah. So which is exactly at the 1/3 where 2 vehicles go. So whenever they come and meet, they change their lanes, they go up, and then they go in opposite directions. So they meet, go, they meet, go. So even if this guy dies, then I have the other two guys, they come and meet. So only small part of it area is left out, but the rest of them, both of them cover each other. I'll show in the next simulation wherein, and whenever I have some kind of a information about these depths, which could be any proxy from any of the sensors, then I can change how much of lane width I need just by using the weight of that particular, the concentration of that multiplied by some factor to reduce the length of so reduce the width of my lane. Yeah, I can just use that to cover it up, and just because I am using in the opposite direction on the same lanes, I can actually get a nice, this is the default, and this is where I do a high resolution mapping wherein I have the minimum length thing. So when I want to do an adaptive, it should be between these two guys. So that is where my focus is, that I want to get a fault tolerance, and I want to get more information over here and less information over here, compared to this, how much of time I take versus this much time I take. Yeah. Okay, let's see if it works. Yeah. So this is where they are meeting up and then going, meeting up and then going. Yeah. So it's so look, so it is the high resolution, that is the amount of information I get. Low resolution, this is the amount of information I get, and adaptive is closer to 1, while the percentage amount of time is much more closer to the lower resolution. This is the kind of the trade-off that I am looking out for. Yeah. But okay, the question is it the optimal trade-off? That is still a question. So other thing is when there is a faulty agent, so this guy is dead, and then what happens is the other two guys take over. You can see that now this guy is having low, high, low, high, low, high. They just can adaptively they change it up, and still they are able to cover it up most of the places, except there is only one small lane. Yeah, this is the performance, and this was this we did in Porto a long time ago. Yeah, with 3 vehicles, vehicle 1, vehicle 2, vehicle 3, and this is the mission planner of that, wherein you can see that they are coming here. I'll just show only for one lane, and then they come. They just generate the new lane width points, and then they go up, and then they continue from there. Yeah.
Complete algorithms you have implemented in actual systems.
Yeah, actual systems.
But there you are considering like 3 translational and 2 rotational only, each and your role you are not covering.
Yeah, here is only because it's only waypoints. We are giving only waypoints. So this is the waypoint, and so it will go here. So only yaw is control. Yeah, communication. Yeah, so they have acoustic communication. Acoustic communication. They have acoustic communication. Yeah. So okay, here I didn't put, but there was another experiment wherein the communication failed between these two. So they interchanged the positions, and then they went to the next lane, and then they changed up again. So that also happened because of the communication thing. Okay. We have much. So there was one talk about using multiple vehicles, different types of vehicles for doing coverage. Here we use a UAV and a AUV, where these are the target locations where the AUV should go and visit, so that the UAV will go around, search for the target locations. It will come and give it to the AUV, so that AUV can go and visit that particular target location. A kind of a cooperative mission that you can develop, and then you can do a lot of optimization around it. Like how should your aerial vehicle path be, how can your UAV path be, things like that. Okay, this is a totally different. You can see here this is an AUV with the white color patches. Can you see the white color patches that are coming around? So those are called salp, which sunfish used to eat, and they use it for migration from Atlantic Ocean to down from the Europe side, as well as to down south into the African. So during this place is where they want to check it out, what is it that they eat as they migrate around. So they eat these salps, which we were trying to use and vision to detect, like okay, how much can we look at the density of this salp and do. Okay, yeah, so I'll just do one more. Okay, so this is on the ASV. So we know that bathymetry mapping is a very, very expensive process. So especially for the lakes, where hardly the municipal agencies have any kind of money for that. So we want to do a low cost mapping. Can we do it? So one was doing the same kind of adaptive sampling kind of a framework, where we use we assume a Gaussian process across the entire lake, and then we want to sample it and then see how things will change with respect to where I should sample next. So with minimal number of sampling points, can I have a higher coverage in terms of the information of the bath compared to the a lawn mower kind of a thing. So this is where we did with so this is the ASV we have, which is a kayak tugged up with 200 thrusters and the GPS and then antenna to come back. So this is the kind of map for the entire, I think it was 100 by 50. Okay, I'll just finish it up, okay, very rapidly here on. Yeah, here you can see that if my mapping error with respect to a standard high resolution lawn mower pattern, if I say that I just need only 10% of it, this is the amount of distance that I need to travel. This is using a single beam sonar, okay, that we are using. So here by approximately by around 400 meters I can do this. I can give you a map with a 10% error kind of a thing. So now what I used to spend so much of time and effort, now I can reduce it significantly, and then I can even do multiple kind of maps. Yeah. Okay, so this is the last one, I think so. So this we were trying to do with collision avoidance with the call rigs into picture. Typically call rigs is done with a reflective or a reactive kind of a system, wherein you use tangential potential fields or potential fields to just for only one particular thing. So rather we cast it as a, because you have multiple agents, we cast it as the multi-agent pathfinding, which is a search algorithm in your AI literature that can give you guarantees that it will always find a path which is collision free while satisfying call rigs. Yeah. Here we took only rule number 14 and 17 into account, but you can increase that to other things also. Okay, let me see this. One minute, yeah, I'm getting it done. So this is for the 3 agent case where they are not like head on kind of a thing, and you get a similar kind of a where a rotationally kind of a paths between the vehicles.
This call rigs you have developed, or it is a open source also?
No, call rig is basically the IMO, International Maritime Organization's collision avoidance at sea rules.
Collision avoidance?
Collision avoidance in sea rules. It is published by International Maritime Organization. So all ships have to follow call rig. When 2 ships are crossing, all ships have to follow. With autonomous vehicles, we are trying to bring it into.
Yeah, because they have to operate in the with the people around. Okay, done. Okay. Okay, so this is just another playing which we are doing with the. So other one was when we did the other vehicle, the most expensive was the 2 thrusters, right? So each of them were costing, okay, total was costing around 100. So then we said, okay, let's do this on the river where there is already a flow in the water, and I need to only change my heading angle, which I can use some kind of a fish kind of a fin. We will put, so currently these are like this is the RC control as of now. We are going to make it autonomous with a camera and everything else. So the simulator part we have done. In the summer we will be putting it onto the Narmada to make the changes. Yeah. Okay, that's it. So I have some thoughts on developing and some kind of interoperability so that you do communication and cooperation between all kinds of vehicles, and certainly we need a high fidelity kind of a simulators so that it can help in developing closer to the real world. And mission planners, we are talking about swarms. So existing mission planners which you can use it for deploying multiple vehicles, but if you have a mission which is consisting for a swarm, there is no way for a planner or the mission planner software to understand what is the objective of your entire mission that can decompose things into picture. So you need to decompose into small plans, which then you need to give it to the vehicle and then make it one part of the other. So if you want to do it a large scale system like with the swarms that we are talking about, then the way in which we design the planners, that needs to be changed. Yeah, and of course sensors and which can be loaded as well. That's it. Thank you very much. Which one? The very first one?
Multi-agent system. So you have some. So you have some 3-4 agents that are moving together. So first one.
The very first one, that is it was a cars which we finished 3 years. Yeah, that was with NSTL, which finished 2 years ago. Yeah. Thank you.
Thank you, sir. Thank you for your insightful presentation. So we now invite our final speaker of the seminar, Mr. B. Suresh Kumar, Scientist F from NSTL. B. Suresh Kumar is an accomplished professional with an MTech in Computer Science and Engineering and over 2 decades of experience at NSTL DRDO, where he joined in 2005. He currently heads the embedded software groups and specializes in real-time embedded system and computer visions. His major contribution include the design and development of mission critical embedded software and onboard computer system for heavy and lightweight tropoids, AI-enabled onboard computing and portable launch control system for man-portable AUVs and missions computer system for high endurance AUVs. Sir, may I request kindly deliver the lecture. So you have connected the PPT.
It's working.
No, can you use this one and use this slide changes?
Yeah. Very good evening to all of you. So basically, I will be talking on the AU development, specifically a man-portable AU development that we have taken up at NSTL. So this project was sanctioned by Indian Navy. The requirement was to develop a man-portable AUV specifically for mine countermeasure mission. So AUVs can do multiple missions, but here the primary goal is basically detecting underwater mines, proud mines or ground mines, not a submerged or totally buried mines, but proud mines, then neutralize them. So the challenge was, developing the entire the mission requirement in less than 30 kgs. That was the primary challenge. And most of the subsystems, if you see, like NSTL was very comfortable handling bigger systems, like a 533 or 323 diameter kind of systems. But when we were sizing this application, so we thought it should be realized maybe less than 200 mm of dia. So finally, it come to 160 mm dia of around 1.8 meters length. The challenge was to pack all the sensors, the subsystems, and to meet the endurance requirements of 6 hours basically with 4 to 6 knots speed with the opposite current of 1 knot. So that was the challenge. Going into that, the outline of my presentation is like that. So just I will give a basic introduction on the mine countermeasure, the role of AUVs in mine countermeasure missions. Then I will cover on the basically the development part of. I will not go into deep into the any technology development, but I will be touching upon the subsystems we have developed, the kind of sizing we have did, and another important thing was like AI integration for mine detection and neutralization. Then I will be showing some of the field trial results. Yeah, coming to the mine countermeasures. So that MCM operations generally consist of neutralization, where there are two important steps are involved. The one is mine sweeping, where replicating the target signature so that the mine will explode against the dummy kind of a target. The other one is the mine hunting, where the aim is to positively detect, then neutralize the mine. So this project is specifically targeting the second part, that is mine hunting. So if you see the mine countermeasure phases, it contains different actions, right from detections, where we need to discover or identify the mine-like objects. Then you have to classify whether it is a mine-like object or mine, because when you see particularly with acoustic kind of sensors, whether because we will be looking at the shapes, basically any rock also may look like a mine. So finally you need to positively identify, at least by means of using a camera. Am I audible? Yeah. The mine. So then we can deploy a neutralizer to reacquire the target again to end. Then the AUV which we are developing can carry up to maximum of 4.5 kgs of explosive, which cannot destroy a mine, or I mean which cannot actually damage the mine. But the idea is to go near to the sensors, I mean as close as possible, then explode the charge so that that will damage the sensors basically. So in turn the mine becomes ineffective. So that is the goal. So coming to the comparison of various AUVs available in the world today, which are of man-portable class or in that range, which are specifically developed for mine countermeasure. The NSTL vehicle is around 1.8 meters long, weighing less than 30 kgs, with the endurance of 6 hours, with a maximum speed of 6 knots. So this vehicle is designed for the depth up to 75 meters, because most of the times the mines are deployed in shallow waters. Because if you deploy in the deeper waters, they will not have the impact, the kind of damage they cannot create. So the aim was to even the develop, develop the vehicle which can operate in that zone. Then the main aim was basically a development of a man-portable AUVs for detection, classification and neutralization of ground mines. The scope includes the realization of 2 types of AUVs and communication of these AUVs underwater, exchanging data among the AUVs. Then autonomous target recognition for mine like object detection and neutralization. Then coordinated navigation among movement of the vehicle. That was also another objective. So these are all the specs given by the Navy. It should be less than 30 kgs, less than 2 meters, and it should maintain 6 knots with the endurance of 6 hours. So the project again we divided into 2 variants, because we cannot pack all the sensors and the payload, the warhead in the same carrier because of size constraints and weight constraints. So the first variant is nothing but a surveillance vehicle, which will do the survey, basically identify the mine. So based on the identified location, the neutralizer can be deployed. So this is the surveillance vehicle configuration, which contains underwater camera, acoustic modem, We have a LED flasher for basically for identify the mine, identify the AUV at the end of the mission. Then we have the AOBC, which does the all the computation part, and the primary payloads are like side scan sonar and underwater camera. Then we have the battery module, the surface communication antenna, then actuator, motor, and the propellers. So, this is the neutralizer AUV, where we do not have the side scan sonar, which is not required, because the surveillance vehicle will do that part of the work. So, that portion we are replacing with the 4.5 kgs of warhead. There are the salient features which already I have mentioned. There are the subsystems developed as part of this project. So, other than the acoustic payloads like side scan sonar, acoustic modem and DVL, rest all systems are developed in-house at NSTL. These are the major challenges because of the size and power constraints. Now, we have indigenized even acoustic modem also. The other part like side scan sonar and DVL are yet to be taken up. So, coming to the INS, we needed INS which can because here the navigation accuracy is very important, because we need to go very close to the AUV, because the end game again we are depending on the camera. So, camera underwater if you see hardly will get, we expected it will be 10 meters, but when we tested in open waters it was hardly 5 meters and all. So, your navigation system also should be so accurate. So, this system was developed by one of their sister laboratory called RCI. So, they have taken the MEMS INS and integrated with the DVL. So, without everything it is coming around 100 meters in 100 seconds of kind of drift. With integration of DVL we are getting almost 5 meters accuracy. This is another miniature actuation system developed as part of this project. So, here are the specifications, like it is a 4-channel actuator with 0.4 Newton meters of torque and bandwidth is 2 heads. So, it can move the control surface with the span of plus minus 20 degrees. So, this system is realized within less than 1 kg. So, this is again another important system is our propulsion battery. This is also in-house design, which gives the nominal capacity of 50 Ah, which is meeting our requirements. Coming to the processing part, the intelligence part, the main system was onboard computer. Then again another important requirement to be implemented was the AI based MLO detection. So, and we cannot afford a separate electronics for AI processing and other control and guidance requirements. So, because we do not have the luxury of either space or like weight. So, we needed a single system where it can do all the like mission activities, like a computation part, then data storage, which should have the other features like surface communication module, all sort of things. So, that system is realized with 2 system on modules. The one is the Kriya SOM, which is a AMD system on module, which does the heavy duty of all the mission related activities, including data storage, then communicating with all the subsystems, acquiring data, then executing all our control, then guidance algorithms. Whereas the AI part, the AI workload is implemented with Xavier NX system on module, which is NVIDIA system on module. So, which basically acquires data from sonar and camera. So, which implements the AI based object detection algorithms. And coming to the communication with our launch control system, because of the space constraints, we never had the opportunity to put any kind of tether, because again that calls for the isolation of the lines. Again we need to put some kind of relays for isolation. So, then we thought that we should have the completely wireless communication between the launch control system and the AUV. So, as part of that we have developed a portable launch control system as well. So, then the systems, the payloads or the subsystems requires different powers and different current requirements. So, we design a power circuit board which takes the 24 volt battery output and converts different voltages required for different subsystems in the AUV. So, this is the broad structure of the OBC. So, which consists of two system on modules sitting on a custom carrier board. So, this system including heat sink we could realize in less than 1.25 kgs. So, that was one of the challenges. So, this is how the system looks like, because we need to have a specific shape as well, because we cannot go for a straight COTS or readily available module which may not fit into our AUV with all other constraints, and which is having the all sort of communication or the interface requirements. The another concern in the beginning was because we are going for a GPU based module which consumes lot of power. So, there was a apprehension that it may generate lot of heat and all. So, the thermal analysis was done, and we could see that it is not crossing the limits, and subsequently we did endurance testing also. We tested more than 6 hours by simulating all the loads in full load condition, and it is not crossing the temperature levels. So, these things I will think skip. So, this is how the system architecture looks like. The Kriya SOM, which does all the mission related activities, it contains the PETA Linux, which is embedded Linux as a real time operating system, and all the software modules, everything is implemented in C++ language, whereas Jetson we are using for that AI based MLO detection. All our AI models we are training with PyTorch framework. Training we do use Python, but the final the inference we go with C++. Coming to the PLCS, that portable launch control system. Again the details I will skip due to the paucity of time. So, this is how it looks like. So, we needed a system, a launch control system, because the system needs to communicate with multiple AUVs, and we cannot have one launch control system for each individual AUV. So, then we have devised a mechanism through which a single LCS can talk to multiple AUVs. So, which we create a local network to which all the AUVs can connect, and through which we can give commands, and it needed to be portable. Not only the AUV, even the solution also Navi wanted a totally portable solution. So, the entire mission planning or mission control application was implemented in a tablet. So, which operator can freely move. So, this is how the mission planning or mission planner GUI looks like. So, the same GUI I think Sarva is also showing this here. So, the operator can freely draw the mission plan on top of map. This is the screenshot of one of the lake trials where we did some of the trials. So, the operator can define the path of each AUV, how it should go. He can define the speed, the depth at which it should run, then what are the path length, or if it is a lawnmower, how many legs. So, all sort of things we can operator can define. This is the screenshot of a sea trial where it is showing this portion is like the own position, and this one is the the AUV path where it is supposed to run. So, before launching the AUV, we also do certain kinds of pre-launch checks. We need to initialize the INS or do some kind of subsystem checks. So, this is a GUI through which we can monitor individual subsystems, the status, so that when the system is launched, it is it is expected to work seamlessly. And we can also see the attitudes of the individual AUV. So, when the system is connected to multiple AUVs, here we can see all the list of AUVs connected to the network. So, if it is in the near field, they all will be connected to the Wi-Fi network. If it is not there, then they will automatically switch over to the Wi-Fi network. So, the RF. So, once the mission is done, then we upload the data. Again the same the mission analysis part also we wanted to implement in the same GUI. No, we did underwater also. underwater. No, it's only mission planning only. So we plan the mission and we deploy. Yeah. But if it is in surface runs, when the LCS is in communication with the AUV, then we will be able to clearly see the path of the AUV. Because already you defined the path, whether the AUV is following the same path or not also can be monitored if it is a surface. For underwater, we are not yet established, but still we can track with, not mapped into the GUI, but we are able to track with OEM software, not with our GUI. So once the mission is done, the review or analysis can be done with the same GUI, where the system automatically generates the mission summary, the vehicle name, what was the start time, what was the end time, then how long the what is the endurance of the mission, then the various parameters like what is the maximum depth, average, roll, pitch, yaw. So all sort of information we can get in a single click. And we can see the individual messages also. The data exchange happened between the different subsystems. So everything we log for the post-trial mission review. Then we can plot all the data parameters which we record. So this screen shows the jet plot, where we are showing both the depth as well as the altitude. So we need a single GUI for mission planning, mission review, and as well as the analysis, and a automated report generation also. With single click, the system generates the total comprehensive report consisting of all the parameters. So this is the parameters like all the roll, pitch, yaw we are showing here. And the same GUI we can render the side scan images also. So we need not use the OEM software. When you can replay and you can see the path when the AUV is following a particular path and in a particular position, what was the image of the side scan. So that is also possible here. So coming to the MLO part, the mine-like object detection, this was a big challenge for us because NSTL never handled such kind of task. So then the primary payloads, as I mentioned, was side scan and the camera. Then we studied multiple approaches as per the literature, like traditionally people use image processing techniques or some machine learning based approaches also there. But after considering, then we thought that only the deep learning based approach was the more robust one. But the challenge was these deep learning techniques need a lot of data, which we do not have. So that was one of the challenges. The second part was these side scan sonars, they give the acoustic pings. So generally what they do is we connect the sonar directly to the OEM software which runs on a PC. You can real time you can plot, you can see the waterfall images, but same is not useful in actual real time scenario. So you need to process the data on the fly, then generate the image and feed these generated images to your deep learning algorithm where you can do the detection part. So that was also another challenge, and again the deploying this onto the embedded hardware, that was also another challenge task for us. So then we started collecting data. We visited multiple agencies in Navy, but unfortunately we could not get any sort of mine images. Then we procured a ROV fitted with a side scan sonar. So actually it has that single frequency 450 kilohertz sonar, which has the range of 100 meters. So we taken this ROV, then we deployed, because NSTL also develops the mines. We have the mines, so we have taken these mines to the harbor and lakes. Then we collected data. That's how we started building our data set. So this is some of the harbor trials. This is we call a manta mine or lightweight mine. So this is how the mine images looks when you are scanning with the side scan sonar. So sometimes it's very difficult for the human also to say that this is a mine or mine like object. So that is a challenge. So this is the cylindrical mine, and these are all the images of the cylindrical mine with the side scan sonar. So then another work with IAC, we have worked with Professor Suresh Sundaram, because whatever data set we gathered, and after even doing some of the standard data augmentation like some flipping or adding some salt, pepper, all these things. So, the model was not generalizing well. So, then we thought why not use some kind of synthetic data. So, that is where they helped us to develop diffusion based models which can train on the existing data and generate synthetic data. So, that has helped us to improve the model accuracy by more than 4%. So, here are the top one is the actual images where you can see the synthetic images, they are very closely matching, both I mean semantically also they are very close. So, then the other part which I was talking was this real time generation of the images. So, what we do is we collect the sonar pings in the real time, then each ping we collect and then we convert that into as a pixel values. So, once we collect those pixels, then the number of pings also we take. So, our ping window is like 200. So, once we collect the 200 pings, then we generate an image. So, that image again goes under some kind of intensity or basically normalization, which consists of intensity normalization, slant range correction, speed correction, then attitude correction. Otherwise, you will not get the very good image, which may not be very good for the detection algorithm to give better results. So, this is another challenge. So, once that is done, I mean finally we could generate side scan sonar data set of about 9,700 images. Then this data we have used for training the model. So, once we train the model, we get the PT file because we are using a PyTorch framework. That PT file we are converting into a ONNX, which is like Open Neural Network Exchange format. Then once that is done, we quantize the model, because if you run the model as it is, it takes lot of time. So, once you quantize, because each the model consists of the all the weights and biases which gets generated out of the model training, by default they get generated into 32-bit floating point. So, if you can reduce from 32 to 16-bit, then your computation load will come down. So, which effectively increases the your frame rate basically, because we need a real time kind of performance. Because as the AUV is moving on the fly, you need to do all kind of processing. So, there will be some trade off, you may have 3 to 5% of reduction in the accuracy, but still that is manageable. So, that we convert into engine file and which we deploy into the OBC, with then we do the inference part. No, this is all offline, the block box consists offline, this part is online. So, once you convert the engine file, that is loaded into the OBC, and in real time when AUV is running, it gets the data from side scan sonar, then it generates the image, because already trained model is sitting on the OBC, then we do the inference. So, these are some of the training results. We started working with open source model, right from YOLO 5, YOLO 11, YOLO 8, all sort of models we explored. And there are some of the results in the SMB data. This is our sea keeping and maneuver basing, where we kept the mines, then we did the scanning. It looks very nice because it is a like concrete floor. You can clearly see the mines here, but same is not in the case of open water trials. There are the detection of mines with the what are the figures you see there is a confidence level. So, in this case we can say that it is detected as a Mantha mine with 95% detection confidence. So, this is again on the Harvard data. So, there is a lot of change from the SMB data and Harvard data. So, in Harvard data you can see there is a lot of noise in that. And this is there are the detections on the recorded video, the initial testing which we did. We put the mine in underwater and with different lighting conditions, just to see how the algorithm is behaving. And there are the real time detection again in SMB. So, as the AUV is moving, it is able to detect. There are the initial test results. So, then this is the real time detection on the the camera image. So, you can see 1 or 2 false detections as well. Yeah, this is with camera input. So, and then we moved into like Nagarn Sagar, where we did the dynamic trials. So, you can see the lot of difference between the shape of the mines in different water conditions and different different scenarios. So, that is a challenge. So, no matter how much of data you collect, there is always there is a challenge. And this is how like once the detection is done, we are estimating the position also, because we know the position like AV, then we know the range and bearing. From there we can calculate the estimated position of the mines. So, there are all open water trials in Nagarjuna Sagar trial detection. I think there is some issue with the video. Yeah. All the real time detections in open waters. Then the another work what we did was development of USV, unmanned surface vehicles, in two configurations. One is a monohull, the other one is a catamaran type. So, they carry a USBL. Basically, when we are deploying these AUVs, they are running underwater, and till the completion of the mission, we do not know exactly what is going on. So, we wanted to track them. So, we deployed these USVs with this USBL, and we could track all these AUVs underwater. So, that was one purpose. The other thing was to update the position to the INS as well. As per our simulation, because it is a MEMS INS, we need to surface every 15 minutes to reduce the to correct the drift. So, that involves lot of time in terms of like even energy, then somewhere it will surface, again you take the fix, again it should dive to a specific position, because it is a survey mission, you cannot leave any of the area uncovered. So, that was a challenge. So, then we thought, why do not we deploy these USVs which will be running in the surface, they have the GPS connectivity always, they can always pass on this data to the AUVs running underwater, so that they can correct their own positions. So, this is another work. Then we did acoustic modem testing also, the communication between multiple AUVs when they are running underwater. So, we started with ROV, we fitted one acoustic modem in ROV, then with static modem. I mean, these are all the different scenarios, multiple AUVs or multiple ROVs. So, these are the things we did in Nagarjuna Sagar. So, we could test seamless communication up to 1450 meters with the Evologics modem. So, yeah, so this is the thing. So, this is another token based mesh networking protocol, which is developed by another young scientist lab in Hyderabad. So, basically when AVs are deployed multiple numbers, they need to exchange data, so that always you have the information of neighboring AVs. So, but again it works in a half duplex. So, who should transmit, that also important. So, on what criteria you need to decide. So, for that the young scientist lab developed a mesh networking protocol, it is based on a token passing. So, we could successfully test those protocols in dynamic trials. So, this again I think this I can skip, which these are already explained. So, a gazebo ROS based swarm simulator they have developed, where we could do the side scan sonar simulation also. So, I am skipping that. Then we did multiple AUV trials in SMB initially. We started with 2 vehicles, but obviously because of very shallow waters of 5 meters, acoustic communication was not at all good in this scenario. So, this was initial trials in SMB, and we moved on to lake trials in Vizag steel plant, where we fine tune all our control, the dynamics. So, we went to harbor, because the positive buoyancy is hardly 350 grams, and you know the density of water changes, based on that your buoyancy changes. So, trimming that also very challenging task. So, after that we again tune those dynamic parameters, then we went for the harbor trials before actually proceeding into actual open sea trials. So, the harbor trials we did with Indian Navy, that is a surveillance vehicle, whereas this was the neutralizer vehicle. So, then we did a endurance trial also, where we need to demonstrate Navy the 4 hours of endurance, and the critical part was that again navigational accuracies, but because we had only 1 square meter kilometer kind of space in the lake. So, we gave basically circles only to maintain the AUV within that zone. The yellow dots which you have seen is are the GPS points. So, what we did is randomly we made the AUVs to surface in between to see the how much drift is there. So, these are all the points, yellow points, where the vehicle has run on the surface, they can dive down. So, this has helped us to fine tune our navigation algorithms as well. So, this is a trial summary video which we did in, this is a facility in Nagarn Sagar in Hyderabad. So, this is the mission planning phase, where we deployed 4 AUVs at a time. This is the USV kept on surface, which is tracking. So, you can see the track here. This is a tracking on a OEM software. This is yet to be integrated in our mission planner. There are the test results, mine detection. Anyway, this is part of SMB trial only. So, at the end of the mission, again all the AUVs are enabled with go to home. So, they automatically come to the home location set position, where we can recover, and then I will do the analysis, mission analysis. Yeah. So, coming to the conclusion, we can successfully configure, then successfully develop and test and evaluate these AUVs. We could implement like real time mine like object detection, deep learning based models have been successfully deployed. We could establish the token based mesh networking protocol for multi AUV communication, and the challenges what we see is that true swarming, which we could not attempt at. So, that is another challenge because of the latencies, then that is one of the challenges in underwater conditions, based on which I mean the way should take the own decisions for reactive path planning. The other one is the autonomous launching and docking, that is another thing which we are looking for. Then the DVL denied navigation, like we talk about GPS denied, but what happens is even the DVL also may not give the correct output always, because DVL is nothing but it is a like high frequency, it is a active sonar. Based on the seabed you may not get, and particularly when it is doing diving and pitching up, pitching down, we may not get the proper echoes, where then your velocity may not get the correct values. So, because our INS is purely depending on velocities to compute its positions, that was the one of the challenges. So, in this front we are working with IAC again, where they are trying to develop a learning based algorithms, lightweight learning based algorithms which can sit inside the INS itself, and based on the INS quality, I mean the DVL the beam quality, they can switch over to the estimated values, so that your INS solution always is corrected. The other one is the AML integration, which I think Sara also mentioned. Now, at present for each AUV we are manually planning, and we need to feed the GPS locations or draw the map where the AUV should run. But I think future we should see that the operator should enter into natural language. You define the area, then based on that the number of AUVs, then automatically the mission plan should generate, and it should get loaded into the AUVs. So, maybe we can think in that direction too. So, that is it. Thank you. Thank you very much. Yeah. Yes, it is possible, because we could do that, but we cannot say always 100%. So, the finally we should confirm with camera, because we see lot of rocks or some other objects also, they also look like mine only, because ultimately the side scan sonar is give a shadow, so which may look like a mine, but again finally we should confirm with camera. Yeah, machine learning again it is like a probabilistic thing. So, we should before actually deploying the neutralizer, we should positively confirm. Actually parallelly we are working on ROV also with neutralizer, where the operator will be in control. So, if he can see in real time in the monitor and see that whether really it is mine or not. Then the other challenge was because the mines are like 5 to 6 meters and your damage radius itself is 5 meters and your navigational accuracy. Yeah, so there are two ways. One is the neutralizer is sacrificial itself. So, once it goes very near to the mine, so it will explode and in turn it will cause damage to the sensors. So, which is very I mean ambitious thing, because it is moving at a speed, then you have to detect exactly, you have to drop, or any 4 or 5 meters kind of error also, then it may not totally have that kind of impact. So, that is where we are proposing a ROV solution for neutralization, where the operator can precisely place these explosives. So, already that is in the advanced stage of development. The exploders are already developed, it has fitted into the ROVs, where they can go and I mean drop near the this thing. Yeah. So, Navy wanted a AUV, but when we proposed, so a lot of debate was there. So, parallelly we have taken up that task. So, hope it is little bit I mean a little interesting. Yeah, thank you very much for your patience.
Thank you, sir. Thank you for your valuable insights. As we come to the end of this seminar, so it is time to express our gratitude. Respected chief guests, distinguished dignitaries, eminent speakers, and dear participants. On behalf of DRDO Industry Academia Center of Excellence, IIT Kharagpur, it is my great honor to be propose a vote of thanks at the conclusion of the enriching program. First and foremost, we express our heartfelt gratitude to our honorable chief guest, Dr. Samir V. Kamath, Secretary, Department of Defense R&D and Chairman, DRDO, for his inspiring inaugural address and visionary guidance. We sincerely thank Sri L.C. Mangal and Dr. N. Ranjana for their valuable presence and insightful words. Our deep appreciation to Professor Suman Chakrabarty for his encouragement and continued support for his research and collaborations. We extend our sincere thanks to our keynote speaker, Dr. Abraham Varghese, and all our distinguished invited speaker, Dr. C.S. Kumar, Dr. Sambhunath Nandi, Professor P.V. Sujit, and Mr. B. Suresh Kumar for their insightful, enriching lectures. We are especially grateful to Dr. Deepak Kumar Das, Director DIA-CoE, for his leadership, vision, and warm welcome address that set the tone of today's program. We also extend our sincere thanks to the students whose dedication made this event a grand success, and a special word of appreciation goes to the security and maintenance staff for their consistent support. We also appreciate the accommodation and lunch provided by TGH. Last but not the least, we acknowledge the sincere and hard work done behind the scene by DIA-CoE staff to successfully arrange today's event. With sincere gratitude to everyone present, and we formally conclude today's program. Thank you all. We have a wonderful day ahead. And on the last, I have a request. There is a snacks and tea as arranged outside the hall. Please have, then we can leave the sessions. Thank you all for your support.